Yes, so today for this session, we intend to show you the three main results for each project that we present for today, and we will also suggest different challenges to be addressed in the future. What I suggested here is to introduce the Trustworthy AI Cluster in a couple of minutes. Then each project will present its own results and current or promising results, because all these projects are not achieved, and plus the different challenges. I suggest also to mix 2 and 3, because it's probably easier when the speaker will present you the results, for instance, to interact with us, to be sure that we understood perfectly what we want to present, and then we will have final discussions to select the most representative or the 3 results and the 3 challenges that will be presented in the afternoon. Okay, next slide, please. So this is the Trustworthy AI Cluster. We are 9 sibling projects for the same goal. So quickly on the next slide, you will see. So we don't have time to present the content of all these sibling projects, but just keep in mind that unfortunately only 4 of them will be presented today. That will be Bonnefous, FXplain, TALON, and Ultimate. So don't worry, each speaker will present briefly the content of this project, and then present the different results and challenges. Let's start with the first one. So these are the 4 projects that accepted to present the results today. So I will suggest that the speakers that are remote will start, because if the connection is okay now, let's take benefit of that. Very pessimistic. So if you can hear me, who from Self-Explain or even Pro would like to start? Jaume from Self-Explain, are you ready to present?
Yes, I'm ready. I'm ready if you wish.
Yes, please start. So let's try to respect around 10 minutes.
Okay, just let me.
We have enough time for questions, for instance.
Okay, so let me share my screen. This one.
In any case, I think we have your slides.
Okay. You should see my slides, right?
Just wait a minute. Did you change your slides in comparison with what you sent to me?
No. I mean, they should be the same.
So I think it's better for us to present the slides that we have that are the same.
Okay. Then I stop sharing, and you will be sharing?
Yes, please. It would be easier.
Okay.
Can you see the slides?
Yes, I see the introductory slide you have now. Yes.
So please say next slide if when you want to.
Okay, so just to put the audience in context, Safe Explain, the aim of Safe Explain is, in few words, bringing AI-based solution, and in particular deep learning solutions, to be used in safety critical systems with all the complexities that this inbreds. Okay, so we can move to the next slide. So here you should. Okay, we can jump directly to the next slide. I will be introducing the consortium later. So in essence, I mean, we realize that the AI is everywhere. I would say everywhere in any functionality, especially in autonomous systems. I mean, you can think of any system based on a computer vision. I mean, anything that relates to object detection, tracking, path planning, even monitoring the driver in a car. This is something that is only done efficiently building on AI. But I would say the problem is that until today, this is generally done only for what we call fail-safe systems, meaning that we use this AI functionality, but it is not designed in accordance with safety-relevant development processes. And what we do is we take this piece of, let's say, AI software, we put it there, and we put all surrounding logic and software able to monitor when this AI software is failing, and then this, let's say, other software, classical software, is the one taking care of the safety of the overall thing. And this works as long as you have a safe state, meaning that, for instance, you can think, for instance, on a train, you could say, okay, my train is driving autonomously, but eventually, if anything goes wrong, I stop the train. Why? Because I know that I can stop the train. I mean, I know that the train is at a sufficient distance of other trains in front or behind. I know that, let's say, I can simply just stop the train. It's bad for, I mean, for availability. The passengers won't be happy, but this is a safe decision in that sense. However, if you think on, for instance, on an autonomous car, this is no longer possible. You can think of an autonomous car driving at 100 or 140 kilometers per hour in the highway, all surrounded by cars. You cannot simply stop the car. I mean, that can easily produce a crash. And then, so basically, you need to, despite a failure in your AI software, you need to still make AI logic to work and take your car at least to a safe place where you could, let's say, reach this safe state. But it's not something immediate. I mean, at the end, you need this operation, and in essence, basically, this implies that your AI software inherits safety requirements, and this clashes completely with the current practice for safety critical systems, because AI software is completely different to any software you may use in a typical safety critical system, because it's empirical. I mean, it's not developed top down from let's say, from goals, requirements, software architecture until implementation. Is more created as an implementation that works, and then you play a bit with the quality and the robustness, but it's kind of a empirical development. It's based on data, meaning that in a typical control system, you build the algorithm and data is only used to test. In AI, you know that the data is used to train the system, so in essence, is part of the design of your AI model. It's not correct by construction. I mean, it's normally, I mean, a safety critical system software is intended to be always correct. This is because of the process we follow to design the software and then to validate it. But I mean, with AI, we know that we have accuracies. We know that it has mispredictions. We know that it's not always correct. And also, I mean, its architecture is generally monolithical, meaning that you have a model with all parameters depending on each other. And this is something that you cannot just manage with the typical divide and conquer strategy. So let's move to the next slide. So, of course, the ambition of Safe Explain is changing this, is providing a way to incorporate AI software in the development of safety critical systems. This means that we want to make AI to adhere to this safety culture without breaking those things that make AI models to work so good in terms of quality and also in terms of performance. And we want to make this for a variety of safety requirements. It's not just a narrow case we want to tackle, is that we want this to be a solution that matches the needs of different applications domains, different degrees of integrity you may need for your system. And I mean, so far, SafeXplain is, I think, in very good shape to meet these objectives. The consortium, I mean, Barcelona Supercomputing Center is leading the consortium, but we are 6 partners with different expertise, covering from certification aspects to explainability aspects for AI to, I mean, to software frameworks to be deployed on real critical systems. And also, I mean, we have a number of use cases in place. So let's move to the next slide, please. So I would say that the most remarkable results are, let's say, the complete structure we have built to enable the use of AI in safety critical systems. In essence, what we had to do is first extend the development process. I mean, all those steps that you need to create, in this case, your software. So that we can incorporate AI. I mean, AI doesn't follow the typical process, so we had to incorporate a number of steps that allow us gain confidence on that the fact that our design will be correct by construction. This implies, let's say, our second step. I mean, let's say the second box on the right implies having a software architecture especially tuned for AI. So we have the typical, I would say, supervision and diagnosis layers you have in a safety critical system to manage any misbehavior. But in this case, we extend this with AI specific supervision. For instance, this is all the technology based on explainability. So we are able to monitor whether the inputs, for instance, belong to the set of inputs we are using for training our model. So we can tell, okay, don't trust your model because you are using input that is completely different of what you were using for training your model. I mean, these kind of technologies are incorporated just to provide this kind of safety back around your AI model. And then also we have built the software stack so that all these components, all this supervision, diagnosis, and let's say not only the AI specific, but also the classic diagnosis are in place. So these are kind of the let's say the 3 pieces that only when you have the 3 of them, you know that you can make it. So I think that this is, I would say, the most remarkable result we have for the project. So we can move to the next slide. And of course, I mean, this is a research project. We have not built the product. The good thing is that we have already passed the review against certification and qualification, let's say, standards by TÜV Rheinland. So we know that the process is strong, is robust, is solid, is in accordance with what should be used in industry. We have tested this and we are completing the test against 3 different use cases in the automotive, in the space and railway domains. So we know that it works in domains with different constraints. But still, I mean, of course, there's a gap for a true commercial adoption. I mean, if you think of a real system, it's not just a demonstrator with some control conditions, or let's say with a limited size of deployment because of the limitations you have in a 3-year project with limited funds. So now the next steps are really running pilot projects with commercial size use cases. We have to further automate the processes and tools. I mean, there are a number of things that we know how to do, but it's something that at some point we are taking decisions based on the use case in a, let's say, in a quite a, I would say, manual manner, meaning that it comes from a dialogue. And at some point we have to automate this to ease the adoption and also to let the end users gain confidence. And we have to mature the tool set, of course. I mean, we are talking about a tool set that may be in the range of TRL 4 or 5 in some cases, but this is far from something that you can deploy in a let's say in a real industrial project as of today. And of course, I mean, in the longer term, we want to extend our solutions to newer AI technologies to let learning during operation those systems. So far, we are considering systems that are trained prior deployment. Okay, at some point, we'll be able to also incorporate the systems that learn during operation and still adhere to, let's say, to these safety principles. This will require further research, and also the use of more advanced AI technologies like large language models, generative AI, which for now we didn't include just to make the problem I mean amenable for the size of the project. So in essence, this is the status of Safe Explain as of today.
Previous one, please. Thank you, Jaume.
You're welcome.
There any question for Jaume? Yes, please.
Can you hear me, James?
Yes, I can hear you.
Yeah, thank you. Martin Serrano from the Insight Center for Robotics in Ireland. I'm very surprised, and thank you for the presentation. I think it's a very good summary of an overview of the project. But I'm very surprised that you mentioned that AI, software, data is going to solve the problem of critical infrastructures. My question is how this is separated from the critical infrastructure, security, and protection, because before AI, the critical infrastructures exist, and somehow railways, somehow ships, somehow manufacturing plants still work. So what is the added value in this approach? Maybe I misunderstand this part that software is going to save the critical infrastructures, but can you elaborate in how this is matched in particularly in industrial scenarios? Because at least for me, it's not clear how AI is going to complement, replace, or enhance the current critical infrastructure security and trust. Because we're talking about trustworthiness, right? And all these three elements and the principles that you mentioned are valid, but the linkage.
So let's say that the reason to bring AI to these systems is twofold. One of them is for some functionalities to replace human decisions. Okay, so
Yes.
of course, I mean, you need to be more trustable or more robust than a human. Otherwise, I mean, this replacement is not that good. Sometimes it's not that you need to be better, but the fact is that perhaps putting a human in that system would put the person at risk. Okay, so you really need to replace that for an embedded system without a human intervention. And the other part, I would say, the main goal of including AI in these systems is to gain functionality. I mean, it's to basically to gain functionality. Things that I mean, you can think, for instance, in disabled people today. I mean, they need the support of some other people to take them to for instance to the hospital or to anywhere. If you are able to build an autonomous car that is able to be driven on itself, I mean, it doesn't matter whether that person can drive or cannot drive. I mean, you just need that person to get into that car and that car to take that person anywhere. And let's say you remove I mean, you allow this person to gain let's say autonomy. Okay. So these are just examples. I mean, you really want your systems to be intelligent and to, let's say, to be autonomous. And this, I mean, as of today, there are many functionalities that are only, let's say, accurate enough if built on AI. But the problem is that it's not just putting something that works, but something that you are confident that it will work despite of anything. Okay, and this is the challenge. I mean, we know that exactly the problem we are, I mean, the challenge we are facing is that AI is not just software that is designed and validated as any other control software you have in a safety critical system. I mean, its development process is completely different, and what we have been doing is trying to reconcile both let's say both worlds. I mean, we know that we cannot change completely AI software. I mean, that's something that at some point it would be too complex, too costly. It would likely cost accuracy because we would be changing the software itself. it would put a lot of problems to allow incorporating new solutions that are coming from the, let's say, from the AI community. And these solutions are coming extremely, extremely fast. And if we need to, let's say, to go through long periods of modifications and developments to be able to adopt these technologies, we will be always late. And ultimately, I mean, we want to, let's say, to ease this, let's say, this adoption, and that's why we are building this process that allows us to tell whether our system is good enough. I mean, in many cases, I mean, industry, if you think in let's say avionics and automotive, they are already working hard to make their solutions robust. But the problem is providing a process that allows you to tell when your system is robust enough, and this is what we have been doing.
Yes, James, thank you. I mean, I'm not doubting on the robustness of systems. And my point, I think you already addressed. So human in the loop has been in there for decades, and human-centric applications came with the software systems, right? So now what we're saying, or what we want to understand, is the trustworthiness, how to achieve more trustworthiness in the system, how to not replace the human, but assist the human with AI. And you mentioned something very critical, which is the machines or the AI will take decisions to assist or take decisions over the humans. I don't think ethically or even liabilities will support that, but I do support that you will say what you said. So it will enhance, it will improve, and it will definitely reduce the time of reaction. And taking your example of rails and trains, we have seen in the last 5 years that many of the accidents are happening by human decisions. And I think the AI should address that to create more trustworthy systems, at least in the railways, but not to replace the humans. I mean, it's well known that there are trains that drive themselves, but when it comes to 300 kilometers per hour, the major mistakes are by humans. So that's why I think the approach is correct. But from my understanding, I'm not clear on how the human in the loop is in the process. But yeah, let's not create a dialogue here. But I think the principles of design should go to incorporate the humans in the loop and to support decisions rather than replace decisions. That's my perspective. I'm sorry for participation. But thank you, James.
I ultimately, I think that there will be a mix of solutions. There will be solutions where you will have just, let's say, something without human interventions. There will be others. I mean, if you, for instance, think on managing a nuclear plant, very likely, even if your AI system is kind of almost perfect, you will always want to have a human behind, and you will use the AI system as a supporting system. There will be always, let's say, both types of solutions depending on the system, I think.
Thank you, Jaume. Another quick question?
I have one quick, sorry, excuse me. This is Shane O'Shaston from TU Eindhoven. So looking at the newer AI solutions, I was wondering if you have been looking as well at agentic AI solutions, which are not just about adjusting the model, as has been suggested so far, but also about combining models with software tools to make them more robust. So I was just wondering if you've looked at agentic AI as part of your future research innovation plans, and perhaps even looking at the digital environment as well to give guidance to those agents to make their work a bit easier.
Thank you.
Okay.
AI is a new research topic, no?
Yes. I mean, because of the, let's say, of the constraints of the project, we kind of adhere to, let's say, to limited AI solutions. In that sense, we were limiting mostly to typical deep learning, I would say, to technologies that were a good starting point to build the overall solution. Of course, I mean, as I was mentioning, there's many more things that need to be embraced for the, let's say, for the improved services, but also for the improved robustness of the solutions.
Just one question from my side, Michel. You talk about your life cycle with AI software components, but do you consider AI algorithm at a given level of your life cycle?
I know that the approach in the case of especially avionics is quite different.
Yeah.
So I'm familiar with that.
you know, you are aware of the future standards that the IRP 6983
Yes.
W lifecycle or V lifecycle.
But I mean, if we think in domains like, for instance, automotive, just to put an example, I don't think they will ever afford to develop their systems this way. So at the end, what we did was kind of accepting that they will end up putting AI there in their systems, and they will use those models that work. I mean, they may do some I would say some retrainings. They will do things to increase robustness, but they won't be changing the algorithms themselves. So I mean that's why we were starting, let's say, with this type of problems where they really want to keep their models because of legacy, because they know how they train their models. They will I mean, and we're helping them on how to build all this process to select the data to train, to select the scenarios to test, and so on, so that in a sense they follow, let's say, the same safety culture they already follow for their existing systems.
Okay, I see your point. Thank you, Jaume.
You're welcome.
I think now we have to go to the next project. Just a comment for your challenge. If you had some LLM in your solutions, are you sure that you won't lose your qualification and certification objective? But this is another question, because it's not so robust.
Yes.
Okay, thank you. I suggest to leave the room to Nikos. Are you there, Nikos?
Yes, I'm here. Can you hear me?
Yes.
Okay, great. So if you like, we can move directly to the presentation. So
yes.
Hi, I'm Nikos Katsuris. I represent
Are you still there, Nikos? I think he lost the connection. So to avoid losing time, do you want to present TALON? So skip to TALON.
I will try to save some time. So hi everyone, I will present you the developments in the TALON project. So TALON, as a high-level description, introduces an AI orchestrator in order to be able to balance resources between cloud and edge using augmented, more intelligent methods and transforming industrial applications. So we focus on the project mainly on robotics and industrial systems. Next slide, please. My name is my name is Stylianos Trevlakis. I represent InnoCube, and I'm a dissemination. No problem. And I'm a dissemination manager of the project. We have selected these three main results for TALON. First of all, the heart of the project is the AI as the cloud orchestrator. And it is backed up by blockchain mechanism for ensuring security and privacy of the data that is handled by the network, as well as explainability framework for increasing trustworthiness and explanations for the project. The key outcome that we try to achieve is bringing intelligence near the edge in a secure, explainable, and efficient manner. So next slide. Starting with the edge to cloud orchestrator, practically we have a need in the recent network deployments to balance the resources and the deployment of different network functions or AI models between the resources in the edge and the cloud in order to exploit most of the underutilized resources wherever they may be. And in this sense, the orchestrator that we developed is prioritizing availability of the network and exploiting these resources. So when we get a request for a service provisioning, practically we have a categorization that states the requirements of this request, this task, and depending on what the AI orchestrator selects as a requirement, we prioritize latency or performance of the network, but we may also prioritize limiting the resource of this service captures. In this respect, we increase the availability of the network resources, but constrained with specific parameters for service provisioning. This is all handled by the orchestrator through intelligent methods, and the benefits that we have achieved through this approach compared to legacy approaches is that we have better reliability for the end user, so they know that the service will be deployed with the requested characteristics. We also increase the performance of the service provisioning because we bring the computation closer to the edge, and this way we can support lower latency constraints in the different services that we have. We mainly focus, as I said before, on robotics. So in case of AR, VR applications that include human-robot collaboration, we probably need to transfer some video or large files, and we don't want to move these files all the way to the cloud in order to perform the intelligence in the cloud. So practically what we do is we perform the computation near the edge servers, and then we just forward the model updates based on the learning in the cloud. And also this gives us a lot of adaptability in that sense, because different models can be trained with data from different locations, and we have built our approach in a model agnostic way. And I will present some information about these aspects in the next slide about explainability. Well, the final benefit in this approach is that our solution is efficient, and we manage to let's say allow more services to be performed the same way, and have also availability of the resources, and the performance does not deteriorate. Next slide. In order to safeguard also privacy and security and create a trusted environment for this AI orchestrator, we took advantage of federated learning, IPFS, which is a distributed file storage system, and blockchain technologies. So the federated learning is used to take advantage of the data that is located in different servers and servers of the network. And each node processes its own data, performs the computation, and updates the models of the AI model, the weights of the AI model, and then uses the client application in order to populate, to store these updated weights in an IPFS service system. So what this service does is encrypts the data that we store and provides you with a hash that is then stored inside the blockchain. This approach is quite different from the standard blockchain scenario where you store the weight updates in the blockchain directly and you don't use an IPFS service, but it gives us a better, a lightweight approach and a higher scalability for the blockchain system. So this way we can ensure the real-time processing requirements of the network as the blockchain can mine more transactions per second, and we can have the performance that is necessary. And it also, we encrypt the information that is stored in the IPFS, in the file storage system, and we have also encryption and authorization for accessing this information through the blockchain. So we create a more trusted environment for managing this data. And the final, next slide please. And the final result that I would like to present is the explainability approach that we used in order to investigate how we can increase trustworthiness from the user's perspective. So all this performance that we saw of the orchestrator needs to be somehow conveyed to the network or the operator users. And we have structured the explainability framework of TALON in 4 trust levels. The first trust level receives the raw data and performs some quality checks and verification using the pandas library, while the second trust level uses the scikit-learn library to perform data processing, attestation, and imbalance detection, like outlier detection, and then forwards the results to trust level 3, where we use SAP and CAM algorithms. These algorithms are model agnostic because we have structured internally in the project an AI model repository that stores the models and some metadata for each model. And this way we can get these models, perform the explanations in trust level 3, and then forward this explanation to trust level 4, where we assess the model robustness and its applicability in the different use cases of the project. This enables us to provide the necessary interpretability and transparency in the orchestration of the network. And this covers the results that I wanted to present. And we can move to the next slide, which practically highlights 2 of the main challenges that we faced, and we think that continue to be relevant even after the completion of the TALON project, especially as we move towards the market and increasing the TRL of the developed components. So the first one is scalability and real-time processing. As we mentioned earlier, edge-to-cloud traffic balancing and security, and doing this in a secure way is a quite open subject. In TALON, we use the AI orchestration in order to be able to balance the resources, and we ensured security through a lightweight hierarchical process for the blockchain that we saw in the previous slides. And this way, we managed to increase the scalability, real-time processing, security, and moving all this processing closer to the edge. While the second challenge that we faced is explainability and trustworthiness of AI models. Most high-performing AI models are usually black box with deep learning ones. We try to abstract, in our case, and perform model-agnostic explanations. Of course, this is limited in the project scope for the models that were developed for the orchestration of the network, but this approach could be taken into account for future works as well. We provide multi-level explanations and real-time interpretability of the models, and we support adaptability in the sense that we can use our frameworks with different types of models as well. The explainability aspects of each model and the reasoning behind the importance of the features is conveyed to the user, and this covers also some parts of the previous question about the human-in-the-loop approach, in the sense that we have we present this feedback to the operator of the network, and then they can supervise if everything is going according to plan in the sense of the available resources, or if the AI algorithms are taking some wrong decision. And this improves the transparency and multi-level explanations of the algorithms and provides seamless integration with current systems. So I think that is all from the TALON project. So I'm happy to answer any questions. Yes, please.
Sweden. I'm wondering, thank you very much for the presentation. I'm wondering, what kind of edge devices do you use? What kind of hardware? Do you need to adapt your AI models to hardware, specific hardware resources and demands?
No, actually, we built the solution on top of Barreteau, so the orchestrator. So practically, what we wanted to do is not focus on specific hardware and avoid having a strict dependency there in order for the system to be interoperable. And this way, we can augment on the existing infrastructure and have a system that eventually a platform for TALON, because we and the project finishes this year, have a platform that can be produced in a provided in a higher TRL level as high as we can get to close to the market.
So your edge is literally edge in a network.
Yes, exactly.
Edge cloud will also be.
Yeah, I got his point because he's looking at or we are looking in the research community to put everything at the device level. Because, for example, Intel and NXT are already building in-chip security, right? And I think you address very well the framework in terms of how to connect, how to interact. But probably when it comes the time to integrate it, requires a bit more of computing capacity. That might be too heavy in terms of computing. But yeah, it's a good job. It's a good approach. I mean, there's restrictions in the devices, right?
Yeah, yes. Yeah, of course, of course. Also, we had a very interesting discussion, especially after the mid-review of the project, about sustainability and how this can connect with these approaches that we develop, and at which point do we pass we break the equilibrium of, in terms of intelligent methods, but at the same time requiring new hardware, new non-sustainable, non-circular, let's say, approaches, and how the project could take that into account and provide something that is interoperable and can work on legacy systems. That's one of the reasons, or one of the big points that we adopted in order to avoid having dependencies on specific hardware architectures or specific, let's say, ARM-based boards, etc. But if we, so for instance, in the project, it is out of the scope to move computations in the client device. So we go until the edge server. But it would be very interesting to see how that can be done in practice, and how we could provide a layer on top that can ensure interoperability between different client devices as well. Maybe the next project. Yes, please.
On this scalability and the interoperability aspects, have you considered moving also and merging with data spaces and all these federated, let's say, organization be part of a larger data space with a lot of clients and having tests in that environment?
Could you elaborate a bit more, because maybe I lack the technical background on the what you mean by data spaces?
Data space. For instance, you can have a company where it produces, let's say, parts for machining metals and things like that to a lot of clients. And then these clients, when operating the manufacturing domain, they have a lot of data from their machines operating, and models running to do maintenance, predict maintenance, things like that. And all this data may be in a cloud to the original partner that creates all the knowledge for the parts, etc., and do some process, or some process done in the edge on the plants. And all these for security reasons, for contract issues, for paying issues, all are run through a data space with specific rules, an owner of the data space, members that are certified to join the data space, and things like that.
I understand.
And it's a more scalable solution.
I completely now I get it. So we focus in the project only on the network, let's say, orchestration, not data orchestration. But it is very interesting the use case you picked, because we have a manufacturing use case in the project, and we actually have machining of metallurgy plant. So yeah, right on top.
Then it's a partner. Then
no, it's Factor from the metallurgy plant. So and UPV is having the interconnection there. But it was a very interesting thing on how we actually set up all this infrastructure in their premises. But we don't consider, let's say, moving data. So we consider data to be static in that sense.
Thank
you.
You talked about data security and privacy against your clients. Can you explain a bit more how it works with the blockchain scheme? Because my understanding is that it's inherently more open, less private. as a
Yeah, of course. Practically, with the blockchain scheme that we developed, we focus on the AI parts. So what we do is we don't want to move data around. So we have some data in a metallurgy plant, and maybe we have different instances or different plants, and each of them have their own data. So in order to have a low latency service, we don't need to move this data. We don't want actually to move this data to a more centralized, like a cloud server, in order to perform the computation there. So in that sense, we increase the security and the privacy of the data because they stay to the owner, the one that created. The blockchain comes into play because it enables us to perform the updates of the model with federated learning. So we have the AI model and we split it in different servers, and each one performs the updates in the model. And they communicate these updates through the blockchain, the IPFS system, back to the central, to the cloud, and say where these let's say model updates are encrypted. So we increase the security in that sense as well. And then the final model that is computed in the cloud server is also accessed only by authorized personnel through the authorized entities through the blockchain.
So it's kind of federated learning with secure aggregation on top for the model updates.
Yes, exactly.
But then when does the blockchain come in? This is the part I'm not
The
following.
blockchain is the one that includes the updates of the models. So we store encrypted updates of the models there.
Yes.
Michel, in terms of scalability, how blockchain or how distributed ledgers, centralization can help?
Doesn't help.
Instead of having it centralized, because I think the efficiency is a trade-off here.
Yeah, exactly. So the blockchain is not, the role of the blockchain is not to help the scalability, but what we try in the sense of scalability, what I mean here is that most blockchain deployments usually populate the blockchain with, the more data you store in the blockchain, the less scalable the solution. So what we do is we have the data stored in the IPFS system, and the blockchain itself is very lightweight because it only contains a hash of the necessary data. So we don't populate, this hash is practically a link to the IPFS system. And IPFS is a decentralized storage system. So in the end, you don't need to move data. When someone requests specific data, it is validated through the blockchain that they have the permissions to access this data, and then they get the data, if necessary, from the IPFS system, from the original location directly. So it's more or less like.
So if we don't use blockchain technologies, ledger technology, and we use traditional centralized database, encrypted, protected, then scalability will be better. That's why I understood. It's a trade-off between.
Yeah, we haven't done the exact comparison in terms of the legacy and with or without blockchain in the project, but I think that with the solution that we provide, scalability would be more or less the same. So we're trying to minimize the impact of the blockchain in scalability.
Just because the concern today on blockchains is against the trustworthy. I mean, the systems might be very more efficient, but its scalability is not created. So, and then when we go into it's more efficient or it's more trustworthy, I mean, we have rejection towards blockchains.
I would like to. I don't want to waste more time because I'm not present, but we can do it offline discussion. I would like to.
We have deployed some
get your view on that.
infrastructure in blockchain for financial sector even, but we go into this trade-off of is it scalable enough, or we should keep in the traditional approach.
Yeah.
And basically, humans or the CEOs don't trust in some technologies because of the risk of vulnerabilities, because of the distributed ledger. Basically, it's distributing the system and giving more entry points for hacking. It's a trade-off, as I said. But I will continue.
Okay,
It's very
okay. I will try to cut up about this.
And just one point to that. The use of the blockchain more probably towards the traceability, right?
Yes, as well.
yeah, I fully will agree with the gentleman that it is contradictory with the trustworthy that it can trace the data.
Okay, yeah.
Yeah, so again, I'm a bit not certain about the use of blockchain.
Yeah, okay. I get the point. I don't know, Michel will probably kick me out of the room if I extend the conversation, but the blockchain is mainly used for security, increasing the security of the system, not directly linked with the trustworthiness of AI and the data.
But that's fine, we can have a chat.
Yeah, yeah.
Thank you, everyone. Thank you. Nikos, are you still there now? Nikos?
Yes, I'm here. I'm sorry about earlier. My computer froze just before I was about to start the presentation. So I guess what can go wrong will go wrong in this case sometimes. So anyway, can we go directly to the presentation?
Yes.
So I'm Nikos Katsuris from the National Center of Scientific Research, Demokritos in Athens, in Greece, and I represent the Evenflow project. So, which is, next slide, please. Its main focus is to develop scalable, formally verifiable, and explainable, interpretable, and explainable neurosymbolic techniques for detecting for complex event recognition and forecasting. This is about being able to timely detect patterns of critical situations in perceptual data streams, which can be high volume, velocity, and dimensionality time series, or video, images, sequences of images, and stuff like that. Being able to detect in a timely fashion critical situations and use these generated forecasts in an effort to take proactive measures instead of reacting in a retrospect fashion. So there are three main pillars, research pillars in the project, and these are the things that I would like to talk about. The first one is that if you're familiar with complex event processing, many times there are domain experts who kind of know what they want to monitor over the incoming data streams, and so they need to have languages that can specify these patterns in, and then they need to have techniques that can bridge these symbolic patterns with perceptual input, being able to match, do this kind of pattern matching, symbolic pattern matching on perceptual input on video, for example, or time series. So one pillar is how do we bridge, and if you don't know these patterns, many times there is a requirement to be able to learn interpretable event-based patterns from data. So combine symbolic or sub-symbolic learning with perceptual data. So one aspect of the project is being able to combine things like that. These techniques can be, in principle, can be at the foundation of autonomous systems, either embodied robotics or in the digital world. So there's a requirement that these things need to be safe, need to be able to operate safely in a trustworthy fashion. So another pillar is about formally verifying the outcomes, the predictions of these techniques. And because we have massive data flows in these cases, we need scalability techniques. And in the project, we are validating these techniques in use cases such as personalized medicine, Industry 4.0, and infrastructure maintenance. But I will focus on the research part of the three main research pillars in the project rather than the applications today. So next slide, please. So the first important result is related to the first research pillar that I referred to, is about neurosymbolic learning and reasoning in temporal settings. So as you probably know, neurosymbolic AI is about mixing deep learning with knowledge representation and reasoning. And the reason for that is because if you do that, then you have good chances to increase the interpretability of the methods, to increase the generalization capacity, the robustness, to increase the sampling complexity, so how many data you need to learn from. And the point here is that there's a huge interest in neurosymbolic AI right now, but unfortunately not a lot of work on temporal settings. So most applications are on atemporal static settings because the real challenge is once you move from instance-based learning, for example, to temporal sequences where you have temporal dependencies between the data. So we've been developing techniques where you can they make it possible to train in an end-to-end fashion perceptive neural networks with event patterns, which are represented in temporal logics or automata, finite state machines, um, which these patterns are either given by domain experts or learned. And the techniques that we've been developing are quite scalable. They are comparable to purely neural techniques in scalability, but they are significantly more data efficient. You can learn these models from much fewer data. They're explainable in principle, so the patterns that we learn, which can be learned jointly with the neural training. These patterns are interpretable, so you can derive explanations, often of probabilistic nature, for the predictions that the system is making. And of course, we have results that show that you can get much better generalization, especially in out-of-distribution settings. So, for example, in tasks that the model has not been explicitly trained on, or different train and test on different scenarios, different videos, and stuff like that. So next slide, please. The second important result I would like to talk about is about how do we formally verify these neurosymbolic models. So we have developing techniques which are the first of their kind in being able to, for neurosymbolic verification, first of the kind in terms of scalability, basically. So the point here is that, of course, as you know, there's classical verification of symbolic nature, like model checking, which is based on satisfiability and the combinatorial optimization, stuff like that. And recently, there's a huge interest in neural network verification, where the main requirement usually is to be able to verify formally the robustness of a neural predictor. So once you perturb the input, how confident can you be that the predictions, the behavior of your neural-based system won't change? And the point is that quite often, as I described in the previous slide, quite often we need to mix, we need to combine this kind of neural predictors with symbolic knowledge. So for example, in the slide, what is shown is a toy application, small application that could be applied in an autonomous driving scenario where you have a pair of neural networks, a neural system. Basically, one is responsible about perception, like for example, detecting stop signs or pedestrians in an image, and the other is a controller. It's responsible about picking the correct action to implement on the steering wheel, for example. And we want to be sure that this neural system it satisfies some constraints which are shown in the top of the slide. And they can specify it quite easily as symbolic constraints. So the idea is that once you perturb the input, you have your unperturbed input and it works well. You are confident that your system behaves securely and safely. But the point is that once you perturb the input, trying to simulate real-world simulations that are difficult to foresee in training, or difficult to obtain data to train with, you want to be certain, you want to be sure that your predictions, the behavior of this neural controller, this neural system will change. And the point is that we combine, to do that, we combine off-the-shelf neural network verification techniques, scalable relaxation-based techniques with knowledge compilation, which what it does, it takes symbolic knowledge and compiles it into differentiable arithmetic circuits. And then we have the whole system is translated into a representation which allows to use these off-the-shelf neural network verification techniques to get bounds, worst-case bounds on the probability that your constraints are satisfied. And the point is that there are very few similar techniques which are based, however, on classical SAT-based verification, and they don't scale, while the methods that we've been developing are highly scalable. Next slide, please. And the third one is about neural training, scalable neural training. So as I said in the beginning, in event-based applications, you're dealing with high volume, velocity, and dimensionality datasets. So you need to have methods that allow for resource-efficient distributed training. And also, once the characteristics of the incoming data change, these methods need to be able to update their models in an incremental fashion with minimum latency and minimum hazard to the predicted behavior of your system. So we have been developing techniques for, in addition to communication efficient distributed training, for continuous learning of training time versus accuracy trade-offs in evolving data streams. And these techniques are able to fine-tune in real time the employed data architecture, so they can, based on the change in the underlying data characteristics, they can search, for example, how beneficial it would be to add or remove layers from a given architecture, combining the employed architecture with the size of the ingested data via stream synopsis specific parameters. And in the slide, you can see an overview of the framework and the tool that has been developed that allows the user to tune and search hyperparameters in real time. So next slide, please. I would like to speak about a very broad and very forward-looking vision, let's say, which is related to the things that we work on Evenflow, which would be a frontier, like for a crucial frontier for AI, being able to build, develop AI systems that are endowed with actual situational awareness, which means that systems that can perceive, understand, so to speak, their environment and project this understanding into the future, making forecasts, and being able to self-adapt this behavior on these forecasts. And to have these systems, in principle, what you need is you need to go beyond the basic pattern matching that contemporary ML can do, and you need to be able to have some kind of mechanism for deeper understanding, drawing deeper connections between the basic elements of your environment, which is what is called world modeling. So structural knowledge constraints and causal models can help in this respect for all the reasons why I explained about neurosymbolic AI. So a crucial frontier, I think, is the development of neurosymbolic world models, which once they can accompany it with formal guarantees in high-stakes applications and efficient collaboration in decentralized multi-agent settings, could be the basis for high-stakes applications, either robotics or fully autonomous systems that live in a digital world, but also in a manner that's explainable and allows humans to intervene, understand the predictions, understand the behavior, intervene, and change what's necessary to change for safety. Okay, and for that, I would like to thank you for your attention and take any questions if you have.
Nikos, any question? Yes, please.
Yeah, I have first of all, I like the idea of the neurosymbolic world models, and I think that really helps with explainability, because just like people, you see their actions, so it makes it more explainable. What I was wondering about is if you looked at selective state systems, other type of AI models.
Selective state systems.
Like Mamba, those kinds of things.
Oh yeah, Mamba, you mean the recent transformer breakthrough, right?
It's an alternative to transformers, yeah.
Yeah. I'm not very familiar with that, but it's definitely something that's, I mean, even in the neurosymbolic community, it's something that has made a splash, but I haven't looked into that yet.
So what I see is modularity is coming into the mix.
Mm-hmm.
So take a transformer model because of its strengths,
Mm-hmm.
we make Mamba because of its strengths, and we're trying to combine different things together.
Right.
That's one of the future challenges. How do we?
Right. Yeah. Like I said, unfortunately, I'm not very familiar with the Mamba architecture, but in principle, I think that neurosymbolic techniques are making their way also in the generative AI front. So you see agentic frameworks where you try to combine LLMs or multimodal foundation models with solvers and off-the-shelf tools of symbolic nature that are trying to kind of align the behavior of the foundation model with the the task as it described in the symbolic knowledge. So I think that there's a lot of work to be done there, and a lot of challenges as well regarding uncertainty handling, scalability, new techniques for efficient combination of knowledge with autoregressive training and things like that.
Yes, please.
Thank you for a very interesting topic. I mean, I also fully sympathize with that notion, with your challenges. Maybe I have a slightly different view on how to achieve this, but my question maybe is a bit narrow. I was wondering, you talked about temporal data processing. So what is
Sorry,
the...
can you repeat the last word?
Yes, I'm wondering about your temporal processing.
Yeah.
My understanding is that the magic in your temporal processing is in the logic. So I'm wondering about the spectrum of your temporal correlations. Do your system pick up some most, let's say, seminal, valuable correlations in time, or
So
how do you capture real time?
As I said, there are two ways to approach this, which are very, very close to one another. The first one is that a domain expert gives you a pattern of these temporal correlations. And what you want to do is train a neural model to align with this pattern. So instead of having a neural model, a neural network try to perform well on a downstream task, which is like, for example, match or forecast a temporal pattern which you don't know in the case of black box setting. What you're trying to do is try to train it so that it respects what the pattern dictates. So that's the kind of that's the simplest approach, which, however, took a significant amount of work and fine-tuning to make it work. And the other thing is, which is more related to what you ask, is that more often than not, you actually don't know the patterns, right? So you have sequences, you have perceptual data streams. You know that there's something there that you want to monitor. You probably have labels at sequence level or at particular points in the data stream that tells you that at this and this and that point there is a pattern. There is the occurrence of a complex event, a critical event. And you need to learn this pattern. So in this case, what we do is we combine symbolic learning with neurosymbolic training in an effort to be able to jointly train a network to extract symbols from your perceptual data, and then you have the symbolic learner that consumes these symbols to learn these temporal patterns. So basically, the critical part of the knowledge here goes to which are the symbols that you need to extract from the perceptual data. So you need to have some knowledge, and based on that, you can learn the temporal correlations of these knowledge primitives. I don't know if this kind of answers your question.
It does. I was just maybe a quick follow-up. So what's the limitation for your long-term dependencies?
Yeah, that's a good question. I couldn't quantify that. I would say that the longer the horizons, the longer the sequences that you're dealing with, the harder the task in terms of scalability to begin with. But in these cases, we can always try to come up with techniques for subsampling, for compressing your sequences somehow, in order to be able to get some initial crude models. And then once you have these crude models which kind of work well, you could perhaps try to elaborate them, give them larger sequences, different tasks, and try to revise your symbolic part and retrain your neural part. Because the good thing with these techniques is that something that you learn from short sequences or from an initial data view, let's say, because of the increased generalization capacity, it has some good characteristics, some good performance in different tasks. So once you prolong the sequences, so you get different tasks, larger sequences, finer granularities, temporal granularities, your initial model will be able, very often will be able to say something useful about, serve as a starting point for revision. You're not starting completely in the dark. So I guess that there are ways to combat the scalability challenges that accompany large sequences and long forecast horizons and stuff like that.
Thank you very much. Thank you.
So as we all have 7 minutes, okay. So I work for the TALON Context Labs. This is the research center from TALON in France. Please, I'm the coordinator of the ultimate project. I will summarize that in the next slide. So regarding this picture, let's consider that as a life cycle. Let's consider a different column here. The 3 stages of this life cycle that we consider here. I mean, bring trustworthiness for hybrid AI. So design and develop this hybrid AI algorithm. Then, second step, evaluate this hybrid AI algorithm in terms of robustness, explainability, reliability, and so on. And third, integrate this hybrid AI algorithm into the demonstrators to show that it works with operational conditions. And transversely to this life cycle, we have to ensure trustworthiness from the beginning to the end. So it is an end-to-end approach, but also not only considering technical stuff, and so on, but also ethics. So what I will show now is around 1 main results per stage, but I will consider that one, and transversely the last one. So for design and development of innovative hybrid AI algorithm, we develop different kind of hybrid AI algorithm. We have here 2 use cases with robots where these robots share the same space as humans. And you can see here an example of also neurosymbolic algorithm where we, at the beginning, define what are the different rules. So we selected as the symbolic part. We used a sort of probabilistic prologue to express these different rules. You have an example of a rule here. This rule means stop for the robots. So here we mix deep learning with these rules, and we use existing models like ROMP model or OLP model with the postnet architecture to recognize this position with this model, and if it matches one of the rules that we defined at the beginning, the robot will recognize this rule and will stop. And we will be able to explain why it behaved. So this is the first example, because we also develop another kind of hybrid AI with deep learning, Markov processes, and so on. This is the first result. Second one, on the next slide. We also developed for the second stage series of different tool methods for evaluation or this hybrid AI algorithm. So these are empirical, statistical, or formal methods. We sorted them according to 3 main trustworthy AI properties. So reliability, robustness, and explainability. These two methods for evaluation are based on either existing AI libraries or have been developed by the different partners, and most of them rely on, let's say, software methods, but we also have a sort of hybrid partner as hybrid environment. I don't know if it is clear here, but you have an arm if you would like to evaluate, for instance, a drone, because you cannot fly here in this environment. And here you can see just here a robot that rolls under a plane. And we display to this robot sort of virtual scene, and we evaluate how the robot reacts depending on how the scene evolves. For instance, if we had an obstacle here where we would like this robot to turn on the right, on the left, or to stop, or to slow down. So this is the kind of tools that we have to evaluate this hybrid AI algorithm that are integrated here in the robot. And the third result on the next slide is more transverse. We, as many projects and as many partners, we usually try to technically define the evaluation of the trustworthiness according different kind of trustworthy AI properties with tools. So we try to quantify this, we try to measure these different trustworthy AI properties. And here we think it is also, in addition of that, also consider ethical values. And this is done here using, as usual, questionnaires that are based on the ethical guidelines for the high-level expert group and on other documents like ethically aligned design document. So you have a series of questions, and we ask the different stakeholders that are involved in this project. And so the use case owners, the hybrid AI developers, the hybrid AI evaluators, and we have this questionnaire. So they have to answer this questionnaire and to say, is this technical requirement your priority, why, and so on. And we observed that by filling this questionnaire, it has sometimes an impact on how the stakeholders think or develop or evaluate, because most of them usually think technically, well, I have to measure that, but there are some ethical questions that they didn't think of. For instance, if we go back to 2 slides before, yes, here, imagine that we would like to have such kind of post, but for a person that is disabled. This is not possible here. You don't have the room. And this is something that people didn't think of before. So we can go back to slide. So just here, so we try to marry the technical approach with this ethical approach together. That was the third result, and now the future challenge that we could address is I observed here that for the second stage, that is evaluate the hybrid AI algorithm, most of the methods that have been used really focus on the connectionist part, because it is more difficult. And it would be also interesting to rely on the knowledge that has been used for training this model, but to go deeper in evaluation to find corner cases where it could be where some issues could happen. Second one is yes, I can say that it's nearly the same as Jaume explained. We consider here only 3 stages in our whole life cycle. We have to consider the whole life cycle at the end. So we have to extend these results to consider what would be the different trustworthy activities that we need for the whole stages of this AI life cycle. So to make this life cycle more mature. Another idea is also that was out of the scope of Ultimate here, but I was thinking of a sort of environment for AI-based risk management, sort of a template that we could instantiate depending on the critical domain that we target. For instance, railway, aeronautics, and so on. So we could rely on AI risk repository. So we could start with MIT one, for instance, and we can manage this risk relying on the NIST AI risk management framework, for instance. But the goal is to fulfill the requirement of a given AI regulation document. So this is how the AI Act is based on. So this is an idea to really decorate it from the ultimate approach, but that's all from my side. Do you have any questions? So, yes.
Good morning. I am Marina Kugura from SMB Consulting Europe. Thank you for your presentation. My question regards the autonomous robots. Could you elaborate a bit more on what does it happen in case the robot fails in recognizing the rule, the pause? I mean, is there a sort of stop button for safeguarding the operators?
In any case, there is a stop button, of course, that is always close to the humans. For sure, but it's not supposed to happen. Because,
but if it happens, because I am an ethics expert and operating in this field, and we have in our project a similar use case. Okay. Not totally the same, but similar. Is there a sort of human oversight for avoiding this situation because it is autonomous? How do you ensure human in the loop and human oversight? This?
Here it is based on rules. So, for instance, you have seen just that rule. Yeah. But there are plenty of rules. For instance, there is a rule that says a human and a robot cannot be at the same moment at the same location. Yeah. So everything is shown on this camera. So there are level of safety that is defined by an estimation of the distance between the human and the robot. So it is defined by this hybrid AI. Say when you are at 1.5 meters, for instance, you have to slow down and so on.
And what does it happen if the system, the autonomous system, does not properly recognize, recognizing the pause or the distance, or if something happens, is there a way, and which is the way to stop the operation and aborting the operation to avoid collision with the human being? I do so, and it doesn't stop. Maybe I'm not well, and it collide with me.
So there is a second stage that is supposed to evaluate these kind of situations. All the situations where there are safety issues. And as I said, so there are plenty of configurations to be evaluated. And the second point is what you have said, really it doesn't work.
There is a human in the room supervising the operations. To stop in case of need.
It depends on the use cases, but yes.
Yeah.
It is, yeah.
Another question.
Yeah.
In the slide with the evaluation tool, you had also bullet saying open source or proprietized.
Yeah.
So it's an open question for you. You're not sure if these evaluation tools should be offered as an open source solution. Do you provide them or you are still?
I push that for that partners share their results, but I have no power to do that. But at each periodic meeting, say we have the AI on-demand platform, and please share your results. So this project is not fully shipped. It is supposed to be shipped at the end of September.
Perhaps you have some papers with the ideas, but not the source code.
Yes, for some of them already published articles, and some of what has been produced are based on existing libraries like Sharp, CAM, something like that. So yes, I suppose that they explain in the article what is the difference between these existing libraries. Yes. We are supposed to. Right, but we are supposed. Yes.
That's the question for litigation, because I think you touched upon something very important. Do you have ambition to create benchmarks, maybe for the community? Or because I think it's very important effort for evaluation, complex.
What is planned today is to deliver some data sets for these robots in different shared area. These data sets are supposed to be delivered for both use cases. I don't know if on open air or AI on-demand platform. Anyway, there will be a link between them. That is the minimum that will be shared to make this open to the community. Okay. Yes.
Maybe last one. It may be just a generic question. I mean, the cluster is called Trustworthy AI, and I perceive that there are some elements from each project that contributes to create trustworthiness of systems. Is there any initiative in the cluster or any position paper amongst all the projects to contribute all together and say, these are the best practices to achieve trustworthiness in AI or even system of systems? Because I think the material, I refer to the open source, might not be the solution, because in AI now is a competition towards business, but at least the principles and methodologies to achieve trustworthiness can come as an output. I would be happy to even contribute on that, right? But the thing is there any ongoing activity in that perspective? Because I think all the projects can contribute on that.
On the ultimate side, we plan to be in touch with standard committees to promote some guidelines about trustworthiness. So from our experience, we develop such trustworthy activities. Maybe it is something that you can push in the standard, or you can make the community aware of that.
Yeah.
But regarding the trustworthy,
I'm coming more from the community perspective, right? Because AirSim is building this trustworthiness AI practices, but it's based on results implementation. And it should be trustworthy. Here, I see elements on security, I see elements on age, I see elements on privacy that all together build the capability. But because it's not a single project addressing everything, it's not tangible as a self-explanatory position, right? And as a standard, you will never get a standard that says this is trustworthiness. But we can get seeds or elements if we promote as a community, as a cluster, hey, wait, this is the white paper, and there are elements that you can get either as open source from one project, as a collective from one standard. Because this is the way how we can progress, right? Some of them will fail because some of them will be just specific for a domain, particular application, but other ones will be more generic, like blockchain, that can be applicable for others and even take lessons to, right, I want to implement it this way instead of the other.
Absolutely. This is something that it is not planned today, but we plan to have a common conference together. All probably 6 out of 9 civil projects are interested in organizing this conference in September, beginning of September.
So we will finish this year, right?
Yes, I think so.
So this is okay. I'm getting public.
But what I can suggest is because there is a monthly meeting for this process, so more for dissemination and communication. But this is a question that I can mention in the next monthly meeting to gather all these good practices for socialness.
Can you repeat the name of the conference?
It's not ready yet, but it should be organized at the 8th and 9th of September at the Barcelona Supercomputing Center. There is no name, so it's rather to collect project from this second project some results. PSC would like to focus on the processes for critical domains only. So we are working on that. This is a plan. This is not, there is no name, there is no website till now. So we will make some refinement when it will be ready. We are supposed to select the 3 main results. From my side, I've seen that there are some common. I think we will find a sort of trade-off of what has been explained today. What I have in mind is to have results about trustworthy AI neuromorphic AI. Please, let's talk about that if you have time. If you are not so angry.
If I was to clear something, I would say that the future of AI is not just models or models and software or models and software and the environment. It is that systems approach. And your last recommendation there was to build environments that do risk management. And I like that idea a lot. So I think that is perhaps one of the findings we should have from the trustworthiness point of view, is it's about the end-to-end chain and managing risk and optimizing so that each part helps the other part to function as best as possible.
There is a shared view between self-explain and ultimate, for instance, to consider this end-to-end approach to bring trustworthiness at each stage. I'm considering more than the stages that, for instance, you consider. But yes.
Just one thing, because what I mean is not just that. You're right. But what I'm saying is that each element influences the other elements. So it's also about thinking end to end and not just at each stage developing risk management or just optimizing on the basis of the needs of that stage. It's about how the environment can improve the AI models functioning. It's how the AI model functioning can work best with perhaps software tools. It's about how do we connect these things, how do we join them together and into a systems approach. I think that is where trustworthiness falls.
Yes, we were discussing here about 2 points. One is about the main result. The other one that we talk about is on future challenge. So I will mention it. It's a future challenge. Yes.
I'm missing the big picture here with respect to what we aim to accomplish. AI systems that are at least as trustworthy as a human if we put the AI model there instead of a human. So we say, okay, it's trustworthy enough to subsidize for a human here, or to make the entire system even more trustworthy than it is if we include our AI solution. So I'm a bit confused on the direction we are researching right now.
Humans are not always trustworthy.
Exactly. That's why I said at least as trustworthy as humans. Yes, what is the benchmark, the goal there?
In any case, the human has to keep in the loop.
Yeah, of course. We see it in a lot of projects there.
And the level of autonomy is given by the humans.
Yeah.
So anyway, the assumptions are provided by humans. And then we have to ensure that the actions that have to be made by robots or drones or something like that have to be trustworthy for the contract that they have to execute. So
So the human is the benchmark. I understand at this point.
I think it's more on the less uncertainty and more transparency. So we probably would like to see to understand what it does. To be honest, okay? It's not necessarily that it has to be 100% correct, but we are sure that it is 80% correct.
And not a black box.
Not 100% black box. It can be black box, but I would like to really understand, predict its moves, okay, so that I can take the right decision.
People are a black box, and I'm confused by all this.
People are black box, and another thing that we've been talking about, like system approach and different ways of ensuring trustworthiness. The thing is that it's very challenging because each and every use cases will be different. Okay, so you need to have a tailored method for each individual use cases when you'll be ensuring trustworthiness. And trustworthiness is not like final exam. You have to ensure the trustworthiness each and every part of the AI development life cycle, starting from your concept generation, data capture, and every stage. So that requires a framework rather than a particular software solution. So it cannot be done through a simple risk assessment, which is very high level. It's not really enough. You have to follow a framework, and you have to tailor the framework for your specific use case that you have got. Then you need to bring different tools together for that particular use case again. So it's not that easy solution that you can have one software solution that will work for everyone, like ChatGPT, answer for everything. Nowadays.
Okay, so let me follow up. This neurosymbolic approach, was it selected because you think it increased the trustworthiness? So let's couple this together to increase trustworthiness. And also the hybrid intelligence, because it's the human in the loop, we expect to have increased trustworthiness. So it's a direction there you follow because of this aspect, or it's let's examine this kind of AI, what it needs to be more trustworthy. What is the process there?
I think the way to proceed is always to design from the beginning to design the trustworthiness. So if we are able to add some correct by constructions like AI, it's perfect. We know that for neuromorphic approach, when you consider deep learning, machine learning, it's not perfect. So you have to reach a given level of trustworthiness. But we have to think, and that's the way also why we had technical values in our approach, because we want at the beginning to fix these levels of trustworthiness and to say we have to design we have to develop, we have to evaluate such a way that we will reach this level. And we are not in the same situation. I think that Jaume that talked about legacy AI. Here now, for the ultimate case, at least, we try really to design and develop
with respect to the end.
Of course, we cannot replace humans, but we could imagine to have processes that is beyond what humans can do. It's always a trade-off.
Thanks.
I think there's one aspect that we haven't touched upon. I mean, it sounds a bit like a cliche, but I think trustworthiness is really multi-dimensional. I think one aspect we haven't touched upon is the reliability. The models, let's say, awareness of traditional boundaries, how they go and to overcome those boundaries. They realize they have limitations in a certain domain, how they go and interact with the environment to adapt. Something we have talked much about. In the first project, we touched upon maybe this security sort of arrangement for the data pipelines, for the outcomes. But in terms of the models, in terms of the whole system, how the system really adapts to enhance enhance.
It is the objective of one of the other use cases of robots that rely on, for instance, reinforcement learning to increase adaptivity. It's not so easy, of course, because you need monitoring for that. In any case, this is not addressed here, but I know that, for instance, in the standard, the future standard for aeronautics, the one that I mentioned, ARP 6983, you consider an operational design domain. This operational design domain comes from the automotive world. This is the envelope, the functional envelope for which we know that we have to ensure the trustworthiness. If you are at the frontier of this envelope, it's not so the system has to give back the power to the humans because it is not sure that he will behave as expected if it is just after this frontier.
Yes, I push that frontier. So I absolutely agree that changing level of autonomy, but also have the ability to be able to push that.
Perhaps some methods that include context as well, and that on the context widget.
So yes,
the answer to the question of what makes a system trustworthy comes from the industrial applications, right? Because each of these projects have their own pilots, their own industrial partners, and they might have this say on what makes the system trustworthy. And of course, the answer will be different. And I also think that every project has either a solution, it's a platform, it's a middleware, but all ones are more contributing to increase trustworthiness. And by putting humans in the loop, by considering this robotics and humans interactions. So I think the holistic, or as was mentioned before, the big picture is to map what the project brings onto the equation of increasing trustworthiness. Now, understanding that trustworthiness is not a single black box, it's a complex ecosystem of security, resilience, safety. Depends on where is the application going towards humans, mostly human safety. It goes towards automation, then it has to be robotic resilience. If we go into more data perspective, then we have to look at this privacy security. So I think this is a good exercise today is a good exercise to see the assets, but not all of them are solutions. Most of them are having an approach to provide something that contributes. Now, if altogether, as a definition, is the trustworthiness, then we have something here, right? But I think the solution comes from the industrial application, because every industrial application will have different needs, different trustworthiness levels. Even you mentioned levels. Who's going to define those levels? I think it's the industrial application. When there's a human in the loop, human intervention, that requires a lot of safety. When there's just machines operating in a production, in a manufacturing plant, semi or fully automated, there's no real safety issues. It's more about resilience.
Yeah. That's why I said that it depends on the critical demand that you target. And if you have a given critical domain, you have some related risk.
Yeah. But still with that, we need to be able to define not a data flow, at least a procedure to ensure trustworthiness from a holistic perspective. If you're coming from a financial domain, so what elements I should consider? If I'm coming more from the ferrovial or trains business, okay, what should I do? If I'm coming from the robotics in terms of manufacturing, what are those principles that I should consider to enable open choose work? I'm going back to the same point of it's a complex, it's a system of systems, as was mentioned, and I support that. Because when we analyze system of systems, we really can capture everything. Now, because it's so complex, we need to decant, we need to go into specifics of each domain, driven by the pilots or driven by the. Now, we also have to be critical in our projects to say, hey, what I'm contributing here? I am a full stack, trustworthy, or just one element of this complex? There is a paper, it's called Pyramid of Security, and then it's just enhancing or highlighting what makes a system safe in terms of data, but it's towards trustworthy system. And there is another standards, another publication that says what makes a system trust in terms of humans. You see, this is all about putting things together and making these projects align with those principles, rather than try to say we have a solution for everything.
Yeah. This is only a 3 years long project, so we can only target the perimeter and we can do for as much as possible. But of course, yes, it would be interesting to gather all this. But again, I think we also have to consider new critical domains with new use cases to reinforce what we have done. What we should decide, I try to find some trade-off from my side from what I heard. So I would like to eat now.
Only 1 hour left for lunch. Maybe your conclusion is that the Adra, what you want to put as a network, is the jump to what you mentioned. It's only a 2-year project. The Adra networks and all the data then collected can be the tacit knowledge can be available for each 3-year project. Each 3-year project can build on or discard something that doesn't work. So it's not a 3-year project, it's a 3-year project built on hundreds of 3-year projects. Up to Adra networks to demonstrate that now. Adra is not a network, but Adra is supposed to last forever.
What does that mean forever?
At least more than 3 or 4 years.
In TRI interest rate, I cannot wait that. Forever, no, I don't do that.
As though as long as people
even the universe is nice. Quite explode.
So it's time for lunch, unless you want to discuss with me. So maybe we shall start.
More than extra.
Hello, everybody. Welcome to the workshop on closing the resource gap. I mean, it seems to be a topic that is horizontal to a lot of projects and initiatives, and definitely in our case at dAIedge we're tackling that problem. The other topic we're going to talk about today is the NOEs. So it's a bit of a hybrid session. We are an NOE representing the edge, Also, we have been tasked to look at the issues of collaboration between NOEs and post NOEs when an NOE stops and the effort need to continue. So myself, I work for an entity called Bonseyes Community Association. I'm also a venture investor, and we participated in a number of edge projects called ZAPS, Bonseyes, Stairway, and dAIedge, and Rebecca, which is a more like a chip-oriented project. The program today, again, it's a bit of a hybrid session. We're going to first have a brief presentation from Mohamed, the project manager, on the project itself. Then we're going to talk about the AI Lighthouse, which is this concept to collaborate between NOEs, try to find a framework collaboration and enhance and improve the collaboration. Then I'm going to talk a bit about the pain points to go from a project to an actual product, from research to industry. Then we're going to talk specifically about one of the new design we've developed at dAIedge to address some of that resources issue, which is the dAIedge VLab. It's a way to collaborate on remote resources between AI actors. And finally, we're going to look at the broader picture and define a few elements of direction on how to enhance that collaborative ecosystem in edge AI. So with no further ado, I'll leave it to Mohamed to talk about the specific project and the AI Lighthouse.
Thank you, Jean-Marc. Good evening, everyone. I'm Mohamed Selim. I'm a researcher at the German Research Center for Artificial Intelligence, in short DFTI, in Germany. And I'm the dAIedge project manager. So starting with what is dAIedge? dAIedge is a network of excellence for distributed, trustworthy, efficient, and scalable AI at the edge. The consortium consists of 36 partners, 14 research institutes, 10 universities, 9 industrial partners, and 3 associations. We come from 15 countries, and the total budget of the project is 14 million. Talking about briefly the main objectives of the project dAIedge. First, we would like to push the edge AI scientific progress, push the foundational research with the emerging software and hardware solutions, try new paradigms, and develop new algorithms and architectures. We also would like to have the United Edge AI community to build a world-class European AI community that is focusing on the edge technologies, and to have scientific exchange programs and FSTPs, and also to have cross-community centers of excellence, which I will come to that later. We also would like to develop a strategic research agenda to provide the vision and the roadmap for the edge AI for the upcoming period of time. And we also lead that by demonstration. We have on-device communication. We have also the methods of federated learning, and we have in the project 3 use cases that I will show you in the next slide. We also try to build a virtual innovation infrastructure, which is the virtual edge AI laboratory, or also the VLab, and try to have benchmarks federation and different test beds. And we would like also, one of the objectives is to have an industrial ecosystem, to have an edge AI on-demand framework, and also the distributed edge AI marketplace and the virtual incubator. So what we provide as innovative services and tools is, the first point is that what we call dAIedge VLab, which you will hear more details about in the upcoming talk. And we also provide the dAIedge marketplace and incubator. So the pilot inside the dAIedge project, we have 3 pilots. The first one is the drone-assisted warehouse security monitoring and inspection. We also have a second use case for doing AI on the edge for satellite image pre-processing directly on the satellite. Nothing is sent, it's directly processed on the satellite. And we also have a third use case, which is high performance, low power edge and fog technologies for the smart cities, also doing AI directly on the edge. So in order to follow the project, I encourage you to visit the website, subscribe to the newsletter, and you can check our X and LinkedIn pages. That's briefly introducing, in just a couple of minutes, the project dAIedge. So this takes me to the second part of my talk today, which is titled Furthering the AI Lighthouse. Advancing AI Lighthouse, Insights, MOEs, Collaboration, and Future. So briefly, the outline of my talk consists of 4 main sections. First, what is the AI Lighthouse? The second part I will introduce is the AI Lighthouse Network. And then I will present to you the findings from the project dAIedge recommendations on the topic AI Lighthouse and share future collaborations and opportunities. And by doing this, remember that the key question that we are trying to answer in this short talk is, how can we foster AI collaboration and synergies between the NOEs? NOEs is short for Networks of Excellences. So first, what is the AI Lighthouse? In short, the AI Lighthouse is a European initiative coordinating AI research networks of excellence. It's part of the EU artificial intelligence strategy, and this initiative requires some coordination of the AI research and development, and this brings the role of the networks of excellence to develop all of that. So what is a network of excellence? This is something I will show you later. So the main objective of the AI Lighthouse is to mobilize the AI community to collaborate on key AI research challenges. And this brings clear objectives to the different projects, or what we call NOEs, is to foster the scientific excellence in AI with each project on its focus. For example, dAIedge is focusing on AI on the edge. There are other NOEs focusing on different topics in the broad domain of AI. And the AI Lighthouse would like as an objective for each NOEs to strengthen the cooperation between the academia and the industry at different topics and between the NOEs themselves, and to develop cooperation mechanisms, and also to support AI made in Europe with the European values, mainly focusing on ethical and trustworthy AI. So the AI Lighthouse, I was mentioning since the beginning several times, NOEs, which is short for Network of Excellence. So it all started in the first start of the projects. The first round of NOEs started in 2020 with 4 main NOEs, Taylor, Humane AI, Elise, and AI for Media. Humane AI, for example, is focusing on human in the loop AI. Taylor is more targeted towards trustworthy AI, and AI for Media is focusing on the media content that is also related to AI and so on. So this was the first round of 4 main NOEs, and as you can see on top comes the vision, which is CSA, Collaboration and Support Coordination and Support Action. And then 2 years after, 2 new NOEs joined the Networks of Excellence, EU Robin, focusing on robotics, AI and robotics, and the HES-SO project for secure and safe AI. And then 1 year after, started 3 new projects. dAIedge is one of them, and Field, focusing, I think, on human and green AI, and the Alias project. So these NOEs, they were joining one after the other, and we see them as the main pillars of the AI Lighthouse. So the AI Lighthouse, it consists of the, let's say, just to depict it, at the very bottom, you have the different NOEs as the main pillars, the networks of excellence with one focusing on a specific domain for AI. And then what comes out of this is something like the Adra, the AI for Europe, Elise, Claire, and different associations. And then comes the industry and private stakeholders, including also, since it's a networking activity, it also has connections to research institutes and academic partners that are even not part of the consortium of the different pillars or the different NOEs. And of course, at the end, it's the end user. And putting all of this together, this forms what we see as the AI Lighthouse. So starting with the existing collaboration mechanisms that were developed over the previous years, starting from 2020, there were scientific research agenda. It came out from the vision CSA. There was the joint SRA, scientific research agenda, and they developed, as I said, as an objective to have communication channels. They developed different communication channels, and they came out with a common visual identity for the NOEs. And what you see here on the bottom right is a screenshot of the ecosystem mapping that was developed through the projects that puts every institute with its strengths and focuses on the AI on the map, literally on the map that you can explore and investigate. It's called ecosystem mapping. And as collaboration mechanisms, we have also cross NOEs group meetings, regular meetings between the project coordinators, between the project managers, between the communication dissemination partners. And we also had community workshops. When we joined in 2023, we joined the latest community workshop, which was the 4th community workshop that happened last year in 2024. And also one outcome of the AI Lighthouse was the AIDA, AI Artificial Intelligence Doctoral Academy, and different more stuff. This is just to give you an idea. What we at dAIedge recommend or find for continuing this AI Lighthouse and even developing it more and pushing it further, we see that we should try to focus on meeting the expectations from the industrial stakeholders, because in each AI Lighthouse, you have the experts of the artificial intelligence focusing on, for example, edge AI or trustworthy or different topics. So you have like a talent hub that is focusing that you can reach if you would like to get information, and also the competitive advantages for the industries. You have also what we can call focusing on the ethics and privacy as a strength with trustworthy AI and keeping these models. We also have we would like to recommend also having a coordination action with a longer duration, because as I introduced, when the first round of NOEs came out, there was the Vision CSA, but Vision finished last year. And we think that it would be good to have maybe a different model or the same repeated model for having a longer duration for coordination among the NOEs. Even with a lightweight, maybe smaller version, because they have now the foundations done. And this would ensure long-term strategic coordination among the NOEs. And one model would be to have a rotating expert leadership, is that you have one NOE, like or more of them, rotating the leadership of this coordination action every 2 years, for example. One other thing is that we recommend for the project exploitability and sustainability is to leverage the AI on-demand platform, motivate that among all the NOEs to push content and on the AI on demand. There is also something that we come up with from dAIedge as a new concept called Studio Financing Grant, which is an extra funding for high potential projects from within the projects, because this might help to bridge, let's say, the gap between from the project to the market readiness. For example, at the end of the project, there might be some, inside each project, there are FSTPs, and some of them would like to have even further funding, and this can be exploited for more and further collaborations. One other thing that we see that it's important for the AI Lighthouse to reach out is to clarify the benefits of having the AI Lighthouse to the external stakeholders, not only the different NOEs consortium partners, but to try to reach out. We try to have active collaboration with industrial stakeholders, to try global and national outreach, European level connections, and also to engage SMEs across multiple levels. This is something that we see that it can be the case that you have like let's say a group of experts in a specific topic inside the AI Lighthouse, and out in the industry you have SMEs and companies and so on. And we are trying to make this connection between all of them. On another topic that we also try to address by having different domains included inside the AI Lighthouse is to come up with a tree-based approach for defragmenting AI terminologies, is to have a hierarchical research tree. It will be dynamic, it will be developed by the different experts through the different NOEs, and it will be even further and further developed. On the level of scientific recommendations, we see that we should come to a pragmatic approach to AI ethics and regulations, because sometimes there is a good balance between innovation and, of course, keeping the ethics, and it's important to try to have the balance between both, and also to focus on what we call niche opportunities in Europe. Instead of like competing with existing methods, we should try to look and find new opportunities, something that was not exploited before, to try to have more projects going in these directions. And this would also strengthen Europe's position in embedded AI. This is also something important. We have the RISC-V architecture. We have different technologies that were, let's say, made in Europe, and we try to strengthen all of that. Finally, we call this part an AI lighthouse at light speed towards more flexibility. As you have seen, the AI, artificial intelligence rapid evolution is quite fast, and it requires from the experts to have more flexibility. And this means to have more, let's say, FSTPs or cascade funding for faster innovation, because more and more technologies are coming every month, every 2 months, you have something new. And sometimes having small projects or FSTPs like tackling these new terminologies and new technologies will be beneficial. We see that in the previous years, the FSTPs made some quite progress, because it comes with, let's say, small companies that they apply for grants and they get it, and then they have direct connection with the experts, and this rapid makes the development quite fast. And at the same time, to have diverse funding approach, not only for small ones, but at the same time, try to support large scale and small targeted projects. There could be a benefit of having one large scale project, but at the same time, also small ones. So in total, this concludes my part of the talk, and I hand it over to Jean-Marc.
Thank you. Maybe there are some questions for on this particular point. Yes.
Yeah, thank you so much for the presentation. I'm Michel from Leitat, it's a research center from Spain. We've been also involved in FSTP projects as well, coming from shop floors for battery industry automation and so on. My question is towards the large scale funding. We all know that in FP10, there's a big conversation going around for large FP10 on how we can go towards large scale funding. What is your recommendation from the network of excellence point of view? Should we have a specific program dedicated for large scale funding, or should we integrate towards such as innovation fund or other type of SEF type of projects?
If I understand your question from properly, you're asking about the large scale funds. Where should it start from? From the FSTPs, or so you mean you're applying for FSTPs, right? But they're not large scale. Is this what you mean?
No, to simplify the question, excuse me about that.
Yeah, no worries.
What is your approach towards the large scale funding from the network point of view?
Okay. What we provide here is a recommendation for the future actions, and we see that based on the different aspects or technologies, if the network of excellence sees a specific direction that requires, let's say, a large scale, it can try to have funding for that for the next, let's say, cycle, or for the next time to build a large scale project. That's how we see it somehow. Would you like to add something to this?
Yeah, I mean, at this point, we're at the recommendation stage. We haven't gone through actually recommending a specific program. I think it's an iterative process, so we are at an early stage of that process, and we're not involved in the prescription of all those projects, those fundings. So, but it's something I'm going to talk about a bit later, which is the funding component, which is clearly or possibly the biggest hurdle for scaling AI in Europe. And we know that it's a well-identified issue and needs to be addressed. So we're kind of raising the awareness here rather than proposing a very prescriptive solution. Exactly. I mean, the announcement we had lately, it's an arms race in size of funding, right? So clearly it's a topic, an urgent topic.
Thank you.
Yeah, you mentioned studio financing grant, and the wording reminds me of Startup Studio. So it's probably on purpose.
Yes.
So what's the objective behind this recommendation? Is it the creation of new companies with some entrepreneurs in residence, or is it more research? Well, why?
So I think it starts from the observation that we have STCP, open calls, a number of initiatives, and then we end up projects after 3 years with very interesting TRL 5, 6 development, and then kind of nowhere to go. So our thought was to embed an extension, a CEO financing to the same actors to bring that TRL further, to accompany that successful, the most successful projects typically would be some open calls project into the next stage of their life. It's an accompaniment studio fund, exactly like you would do in the VC world. Before they get to the world, the miracle situation where they have traction, which a VC would want to see to really do seed funding or Series A.
Any other questions?
Yeah, so you were talking about on one of your slides is that encouraging the use of AIoD, AI on-demand platform. What kind of activities that you already have and what are the plans that you're going to have?
For us as dAIedge, what we have at the moment in AI on demand, we have like the basic information, like the project information, the open calls, the organizations forming dAIedge. This is something that's already there, and I think what we plan to have is also related to the B-Lab, which is more technical, and it will be presented later, is that also to link it there and have it on AI on demand. So AI on demand would be like the, let's say, the hub for AI information that we provide, like let's say the outcomes of the project, we try to push it on AI on demand so it's reachable and all in one place.
Yeah, we have a bit of a few slides on that.
Yes.
You have a quick question. Do you have any link with the Inside Association, which is somehow handling this matter from the industrial point of view? It would be nice to have a link with them, and since also they are somehow participating to the definition of the new project, of the new code, sorry.
You mean the industrial?
Inside Association, which is one of the 3 industrial association in the.
We don't have today. One of the objectives is to draw a list of key stakeholders to join up with, so that I'll take you at your word and can engage with you. Are you part of that association?
I'm not part. I have been in some of their meetings, and I see already a synergy. Because if I understood well, sorry, I'm new of this community. You are mostly academics. They are mostly industrial. So the two at the given point that might combine and might go the same way.
Yeah, that's one of the main points for the Lighthouse is to have this connection and link. It's called the network of excellence, and one part is the networking. And I think, as Jean-Marc said, we don't have it yet, but I think
it's in the roadmap to engage with the downstream industry. The second part of the project, which starts in a couple of months. Yeah, absolutely.
Okay. No more questions. I think
so over to you. It's actually exactly what I want to say a few words on, is to zoom in, 2 things, zoom into Edge, back into Edge specifically, because the NOE considerations are generic, transversal, and also to zoom into the context of what it takes to deliver AI, and here specifically Edge AI, to the industry, which are specific pain points that we have. And just to give some context, I mean, this is not trivial because effectively a lot of industry use cases are moving to the edge. Today you have a proliferation of IoT devices. I think there's like 8 billion edge computing devices. If you add the mobile phones, that number is much bigger. And effectively that enable a number of edge applications that are closer to the data. And together with the emergence of smart cities, there is a need to specifically develop all the technologies around edge AI. So that's a move from the cloud to the edge and to the deep edge is quite observable. In terms of the size, I mean, it shows on the numbers also. If you look at the total size of the global AI edge market, it's planned to reach more than 50 billion, more than 60 billion by 2028. That's hardware and software. The hardware is probably 85% of that, so it's very much hardware related, but the speed of growth, the rate of growth is much higher on the software part of the 15% of that 25 billion is growing much faster. In terms of the European AGI market, the good and the bad news is that it's much smaller. Good news because it can only grow, but the software market is revenues of probably less than $500 million, and the revenues for the AGI accelerator market is bigger, 1.5 billion, and growing at a very high rate. So why is that it's so relevant? To go through some basics. Well, because effectively the benefits of AGI are manifold, and crucially, it's the ability to deliver intelligence close to the data source, not having to resort to the cloud systematically, and also be able to operate offline. So it delivers higher responsiveness, lower latency. It allows you to create a specific security perimeter that is specific to your application, closer to the user. So less leakage in terms of the data and security. It's more resilient. The distributed systems are more resilient than the centralized system. There's no too big to fail risk. It does generate lower processing costs and higher energy efficiency to distribute the workload. Hence, it's more sustainable. And crucially, it gives something that is much more of a soft benefit, which is the ability to regain ownership of your data, of your application, as opposed to have your application, your data sitting at another operator's in another operator's hands. So effectively, what it delivers distributed intelligence, and it fundamentally transforms the edge, the AI architecture, by moving processing closer to the source. The data stays local, the intelligence becomes distributed, hence more resilient, and the network can self-optimize. So there's a lot of benefits that explain that move to the edge. And if you ask the industry, that's a study took from Siemens, I believe, from Schneider Electric, that shows that enterprise value the faster data processing, 43% of them, and enhanced data security. They are key to explain that kind of AGI boom in the enterprise. That is more prevalent than one thing because basically AGI is ubiquitous, it's everywhere. We don't really see, but a car has dozens of sensors that are assessing situation. You go to some large infrastructure, and there are like sensors everywhere to kind of measure the state of the system. So it's ubiquitous and bound to grow because of those benefits. And then if you ask the enterprise, do you think we earlier were in a mature situation? Well, they clearly believe it's still early days. If you look at the response rate, industry in manufacturing, for instance, they see quite a bit of adoption, and the retail also, some a bit less, but you can see there's still a majority of enterprise that see positive traction, although you could see that half full. There's a lot of enterprise that have not embraced AI at the edge yet, possibly because they haven't really found the use case, or maybe because the technology sometimes is not really fully there, but we believe it's more because for the former, in terms of getting the skills and the tools to adopt it. So if you look at the use cases, I'm not going to do a list of all the use cases, but you can select some in manufacturing. You have predictive maintenance, quality control, that are key in the push towards Industry 4.0, smart manufacturing. You have more and more cyber physical system on the shop floor, maintenance, defect detection, repair decision, remote working, all that explains why manufacturing is probably the sweet spot today for the adoption of AGI. Health is also a critical application domain. We've got remote monitoring and telemedicine, the explosion of wearable technologies that more on the consumer side for vital signs, sleep, and the various tracking, early scanning and diagnostics, telesurgery. And one of the big drivers is obviously the ability to also to keep the data secure and private whilst operating on edge and edge device. Infrastructure, considering at large, which is transportation, water, utilities, you see edge devices, or actually you don't see them, but there are edge devices everywhere, in cars, in smart cities now increasingly, in energy and water grids, even in obviously in surveillance and law enforcement. And finally, in the consumer sector, there are billions of sensors in the home for gaming. Smart home is a big application. And here again, one of the benefits it comes with the ability to enhance user privacy on those devices. Actually, it's needed because the risk of abuse of data leakage if you don't put a layer of privacy on those. So this being said, what are the key pain points to scale AI to bring it to the enterprise? And we mentioned a few that were the recommendation. I want to go back a bit on those with a bit more detail. To scale edge AI, you need special skills, you need a scalable infrastructure, you need ready capital, and you need also a conducive regulation environment. So there's also a gap. It's really a wealth gap because in a way, we've got this strange situation where the cost of AI drops on a marginal cost basis, but it increases for an application layer user or builder. The cost of building an application increases every day. If you add the data wall, the cost of data to the massive amount of compute needed, it does bring you into a fairly oligopolistic situation where it's difficult to be a scalable player if you don't have access to capital. By structure, the growth of AI and the governance, the economics are a numbers game. And this is why, I mean, our project is called Distributed AI dAIedge. Everything that can distribute and make the AI ecosystem more collaborative will reduce the marginal cost for new entrants. And the key gap in terms of resources, obviously, is the skills gap. You have to map with the market needs. And today, there's a big shortage of skilled developers and specialists in AI, and specifically in edge computing. 40% of European enterprises have identified a lack of human skills in order to scale their usage of AI and specifically edge AI. And the costs are rising as a result, and it's getting more and more expensive now to get an experienced AI developer in your shop. So we have a few thoughts about how to plug that skills gap, not without going to every of those points, but it's about education and upskilling, identify the needs and develop specific programs to map those needs, collaborate with industry to also make sure those needs are mapping with the actual application needed. Attract global talent in a world that seems to be shrinking in terms of migration. I think it's key to be able to have the ability to source talent from outside our countries. So there's an element of demographics here that is quite crucial, and it might not go the right way at the moment in some countries. And generally develop an innovation ecosystem that foster collaboration, and that's one of the things we're trying to do with those projects, in HES and dAIedge, to bring more skills to the market. Another key resources gap is the infrastructure gap. And here I'll call this very interesting Jevons paradox from an economist of the late 19th century, which basically said that, okay, you can increase supply, but in the world where you increase supply, you also actually increase demand. So when you think you're decreasing the costs, the marginal cost of your input, here in this case, it's consuming AI, the cost of compute and the marginal cost of compute, the marginal cost of storage is dropping, but the actual need, the total need are growing because you buy more GPUs. you buy more compute, more storage. So that's a big issue, and it is compounded by the problem of the growing mismatch between ever expanding model size and the GPU capabilities are not growing fast enough to match that growth of the models. So you get this kind of scissor effect that is adding issues to on top of the problem of absolute cost of the GPUs. So basically lower marginal cost, but then not trickling down to users, to startups effectively. So how to help plug that infrastructure gap? One avenue is to invest into open source tools and to develop new edge AI frameworks and systems. Obviously, adopting open source is by nature collaborative and is supposed to address the access to resources and cost of resources. So there are quite a number of successful efforts in that sector, TensorFlow, Onyx, Torch, engage in open source collaboration as much as one can, leverage community resources, use publicly available data set and pre-trained model to reduce costs, and crucially, develop trustworthy edge AI systems, which includes hardware, software, data, and the full stack. And we're going to show with a bit later with demonstration of the dAIedge VLab that is supposed to, in a modest way, address some element of that infrastructure gap. Also develop more specialized hardware. I'm not going to spend much time here, but there's quite a few exciting in Europe, exciting avenues here to leverage new type of accelerators and use spiky neural networks, leverage edge computing for generative AI. We had an interesting intervention some time ago in a project about how to move LLM's usage into constrained edge devices, which is a very much of an area of growth and interest. And look at the Web3 XR space, which is early stage, but we can see some emerging demand from the industry. So this is where we plug in with AI on demand. Because what is AI on demand? The platform we're talking about, and tomorrow deploy AI, is effectively decentralized AI on demand, a way to kind of create this layer of collaborative between agents where the resources can be shared and optimized to reduce the marginal cost of users. So for edge, it addresses the limitation of the cloud model, which is the issue of latency, transparency, user control, and bandwidth costs. Develop the concept of digital marketplaces where you can provide a more heterogeneous access to resources, as opposed to the classic delivery from the large tech firms. It's a vertical, right? I've got my entire stack. You can buy everything from me, and you'll be fine. So we're looking at horizontal delivery of AI solution, and that can be done through models like the AI on demand. So two or three references here: the AI on demand platform and deploy AI, which was discussed yesterday, this morning, sorry, and will be discussed tomorrow in more detail. So we expect our efforts to plug into, an answer to your question, most of our efforts that are reusable to be channeled into those delivery mechanism, whether it's marketplace or catalog. I think it's a catalog for AI on demand, and it will be a marketplace for deploy AI to different level of distribution. And then our particular project, we're developing this dAIedge VLab that is going to deliver collaborative access to resources initially on benchmarking of models, which is a narrow but very high value service. So to finish about the main gap, maybe is the capital gap, the funding gap, the money gap, right? Which is notoriously a problem to move a project from Europe into a startup or a product. So venture capital is there, but the funding has been strong, but it's kind of actually declining over the last very recently. There's been 90 billion in 24, probably 100 billion in 24, but 30 billion was for OpenAI, right? Globally, global market. So money goes to basically investment go to the few, not the many, right? So there's an inherent oligopolistic model in funding AI. It's arms race for size that is creating an issue for smaller companies, SMEs, and young startups who have to compete with institutions with a much bigger wallet in terms of funding. Also, in terms of geography, the scaling is much faster, easier in the US than in Europe for a number of legacy reasons. So that's a pain point that has to be addressed to avoid our best companies to basically go raise money when they've reached funding of 15 million or 100 million to go to the US or to sell to the US, which seems to be the normal trajectory. There's also a specific issue on Edge AI, which is the valley of death, right? Which is that there is it's a fairly long runway you need when you do deep tech, because you don't create revenues very quickly. You need to invest before you have payback, and it's quite lumpy. So this mismatch is not very attractive to VCs, and hardware and deep tech attract less money from funding VCs at early stage. So that's an issue to deal with. So how to mitigate that? Obviously, some public initiatives exist. The EU has allocated 1.2 billion on some of those projects, including Edge AI. We estimate that up to 30%, if you think about it in a wide scope, cover Edge AI. Recently, countries like Germany and France have invested more than half a trillion in Edge AI. We got some big announcements from the US and followed by France recently that are in 100 billion ticket size. That's in line with the Draghi report that proposed to double the budget of Horizon to 200 billion, sorry, which will be obviously quite transformational. There's a report on competitiveness, Compass report, also refers to Edge AI as a priority, and mentioned in a number of places about public-private partnerships to fill the gap. But clearly, the private sector has to step up, right? It can't be US, can't be state money that makes the heavy lifting only. And then the last, before I open up to the initiative on the Villa, the last big pain point is the regulation pain point. And it's an issue of so it's a story of two worlds. Find the balance, as Mohamed was saying, between the need for fixed rule to protect the users, and also the need for agile development and fast development in a market that is very, very fast paced. Innovation AI happens. Look at DeepSeek, suddenly they announce something and then everybody changed their roadmap. So it is something that is not in sync necessarily with some of the European cycle in terms of projects. If you look at a number of administrative barriers have to be lifted, obviously, easier to say than done, but we need to keep the talent in Europe. There have been some good efforts from the EU to bring some regulation, the EU AI Act, Digital Market Act, Data Governance Act. The problem, though, is that in a world where we see the rise of AI nationalism, you have the risk of what I call regulatory arbitrage, where a good startup will go to where they perceive that the money is and the regulation is fast-paced. So in a world that is going into AI nationalism, concept that I think is quite prevalent these days, it raises a number of issues in terms of the neutrality of AI. There's no global market anymore. It's a very much of a segmented market. So what's next for Edge AI? We still believe at dAIedge that Edge AI can be the edge for Europe, because it does actually map some of the specific competencies and skills we have in Europe, which is the strong skills in academia and research, or affinity for open source models that come also with the fact that we don't have those huge data centers and the big tech company that they have in the US. So we can afford to look at a more decentralized model as opposed to the monopolistic, oligopolistic model of the US or the centralized model in China. We have probably so less dependency on costly cloud resources because we don't have to sell, like Google and Microsoft, in order to sell cloud, we can actually look at edge more easily. We have a natural edge in manufacturing, autonomous robots, artificial intelligence services, Web3 application. Quite a few success stories for hardware companies in Europe and AI services companies, application services. And crucially, we have a more decentralized culture about ethics and the need to protect the individual, which maps well with the concept of distributed AI and edge AI, where you can develop your own ethics and governance on your local network or local device. So these are the few thoughts that I want to share with you. We want to present also now this specific application we have to respond to those issues, which is the VLab to collaborate between users of AGI. Unless there are some questions on the presentation. Yes.
Okay. There was this DeepSeek event or breakthrough. Do you think that now DeepSeek is out? Does it change some elements of this gap here?
I think DeepSeek is more a symptom of something than it's a catalyst of something that's growing, which is the fact that AI has moved radically over the last couple of years into massive compute usage type of model, right? Business model, which is show me how many GPUs you have and you'll be on top of league. And I think people realize that it doesn't have to be that way. And they showed that possibly, I don't know much about the technicality, but they shown that there's a more agile way to optimize the AI delivery chain and use compute, not necessarily be the biggest. You can do a lot being more nimble. And I think the nimbleness is something that is creating havoc in a lot of investors' mind. You know, it's not just about how many GPUs you have, it's also how smart you have to use them. Mm-hmm. And I think that will give some credits to what I was saying earlier. It's about deploying a more efficient network as opposed to just throwing resources at it to beat the next guy, right? So I think a few people are going to reevaluate the need to have a more intelligent deployment strategy as opposed to buying resources.
Thanks for the presentation. I was wondering, you referred to the software side, you referred to the Gen AI elements. You also referred to the hardware side. What is your perspective on the combination of the two? Where does the agent connection lie between the hardware and the software from research and innovation? Should be the
what we witness more and more, and I'm not from the kind of the exploitation side, that quite often they grow in isolation, and that is like a blocker. If you look at, for instance, NVIDIA, they really became very successful when they managed to add a piece of software to their hardware. I think it's and then suddenly they start selling more. So I think what's missing is sometimes integration between hardware and software, and increasingly you'll see some software and hardware and some hardware and software. So I think the line should be a bit more blurred, it seems to me, in terms of the next success stories. And a lot of the project we're looking at is what's missing, right? It's like, so work package on hardware, work package on software, and then you need to have them to communicate with each other. All right.
Thank you, Jean-Marc. So now we are going more in deep to what was presented before, the dAIedge lab, which is a scalable virtual lab for remote experiments on AI-powered edge devices. So I'm Nuria Pazos from Applied Science University of Western Switzerland. Who says applied science? We are more practical, more working directly with the industries, and so we want to make things more concrete. That's why we propose here this implementation of the virtual lab. So yes, maybe to introduce the context. So let's take the use case of AI benchmarking. So meaning how to benchmark train models on edge devices, and we take this as use case. So we are aware that the benchmarking of these training models on different embedded platforms is the way of comparing, the best way of comparing different platforms, different embedded platforms, running the same model and choose among them which is the optimal one for your use case. And this will help also balancing the benefits and risks of AI, of deploying this AI on the embedded platform. But on the other side, we have, so its devices are very heterogeneous and very complex. So we have different tools, different development environments. It takes a lot of time to set up and develop, and they are different. Hardware costs also, it's not always there, and the availability of these platforms may be an issue. So that's why, so we come up with the idea of developing what we call the dAIedge lab, which is a collaborative platform that will enable researchers and developers to conduct experiments and research across various AI devices and domains. So let's have a look a bit deep what this distributed VLab offers. So it's a distributed and decentralized platform for remote experiments on AI-powered edge devices. And the goal is to facilitate AI edge experiments, so launching experiments on different hardware, provide access to all these dedicated resources, tools, and services without less effort for installation and deployment. And we offer the possibility of sharing edge resources on the distributed platform. So meaning not all the devices will be at the same location, they will be distributed different facilities. And we propose a modular concept that allows for third parties or node owners to integrate their solution on the VLab. So the design of the VLab follows a layered model, so which is split into 5 layers. So we can see here on the right side. So we have the user interface, the orchestration layer, the data model processing layer, the edge device layer, and the analytics and reporting. So we can see with the color, the general, so which functionalities are implemented on the user PC or server side, and the yellow ones on the remote node side. As I said before, so this modular architecture allows for easily integrating new nodes on the virtual lab and make them accessible to all the users that would like to launch experiments on it. So here, a more complete implementation of this dAIedge lab. So as mentioned before, we have a distributed platform on the bottom side, in yellow. So they are in different locations. We can have many nodes at the same locations, or managed by the same remote host, but at different facilities. And then on the blue side, we have the user interface, where it's the user, remote user, that we like to launch experiments on the different nodes which are available on the network of nodes. So we have at the user side, we have a user interface, so either a web interface or a API interface that will allow to easily launch these experiments. So on the hardware side, on the edge device layer, so we support for the moment quite a lot of devices, or different type of devices, which can be either high-performance CPUs based on ARM Cortex-A, or GPU from NVIDIA, for example, low-power MCUs also from ST, NXP, etc., RISC-V, and also platforms supporting neural processing units like Qualcomm or the STM32 and also the Vision processing units. They are running operating systems or even Barreteau, some of them, low-cost, low-power microcontrollers. And we also support different kind of runtimes, machine learning runtimes, like a vendor agnostic one, like an NS runtime, TensorFlow Lite, TensorFlow Lite Micro, but also proprietary solutions like TensorRT, OpenAI, or OpenMini. But as I said before, this is a starting point, and now it's open to integrate different platforms and different runtimes. So we see here the first proof of concept for the implementation of the dAIedge lab that has been released in mid-January. And here we see the user interface on the right up side, and on the table here, we can see the report that is provided once the experiment on the specific platform has been launched. So maybe just to visualize it more in detail, so we have a video here. Play.
The video presentation of the dAIedge in. In this video, we will present the dAIedge lab and its features. We will also explain the overall architecture of the VLAB. To access the dAIedge VLAB, you need to request an account from the dAIedge team. Once you have an account, you can log into the VLAB website and start using it. The VLAB provides a user-friendly interface to configure and run benchmarks, visualize results, and compare different models and targets. So here is the web page of the dAIedge VLAB. You can log in using this button. Once you're logged in, you can start a benchmark by pressing the button Start Benchmark. This is the main page to configure and run your benchmarks. The first thing you need to do is to select a device from the available list of targets. The current list of targets seems small, but already represents a wide range of device types. For instance, there are microcontrollers from ST and NXP with very limited resources right over there. There's also bigger devices like the NVIDIA Jetson Nano or the Myriad X from Intel. In fact, this last target was developed by Robotics, a company that is part of the dAIedge software. Furthermore, thanks to the VLAB architecture, you can expand the VLAB capabilities by adding your targets. This will allow your targets to show off its performances to the VLAB user. Once you select the target, you have to choose the runtime you want to use. Some targets have multiple runtimes available. Here, the Jetson has the ONNX runtime and the TensorRT. Let's select TensorRT. Finally, you have to give the model you want to benchmark. Here, you must select a pre-trained model of a given type. In that case, the type is ONNX. Let's select the HES-SO 1X. Once you've done so, you can start the benchmark. Once you start the benchmark, the virtual lab will look for the target you asked for. If it finds it, it will send the model and the configuration to the target. The target then runs the model and sends back the results to the virtual lab. Then the web interface will display the results in a nice manner. While this benchmark is going, I will start 3 other benchmarks. Another benchmark with the Raspberry Pi 5, one next runtime, and this time run the same model. Then I launch another experiment with a microcontroller from the NXP, using TensorFlight and using a very small model. Go back into the same with the ST microcontroller. Once they are all started, we can go in the history tab and we'll see all the experiments as started. Again, find one to see if it finished. Here we can see the results that the Jetson Nano gave us for the HES-SO. We can see that the average inference time is 4.18 milliseconds. We can also see for every layer how long was the inference time. You can also look at the mean inference time per layer in this graph. Here, all the layers are plotted, but you can also select only a few of them. On the history tab, we can see now that all the experiments are done. We can look at the mean inference time. Right from there, we can open the last experiment, the one with the ST microcontroller. We can see that we also have access to all the inference time per layer. We can see here that we have also the minimum, the maximum, and other metrics. We can compare these results with the NXP experiments that we started to. Here, we can see that we use the same model, the same engine, only the target differs. You can see that this specific NXP microcontroller runs this model twice as fast as the ST. Sometimes, some of the experiments you try not succeed. For instance, this one. You can see that the network fails likely due to a lack of memory on the target. Furthermore, thanks to your account, all the results are available to you, regardless of the device you're logging into. Finally, there is a complete documentation that explains to you how to request an account, how to use the VLAB, and how to add a target to the VLAB using the user doc or the developer doc. Thanks for listening. Hope you enjoyed it, and I wish you a great day.
Thanks for listening. So the video is available on YouTube if you want the link, so you can then look at it, but also the documentation is public available, and then you can have a look if you want more details. So if I want to maybe just continue now the slide. So that you understood so easily, you can launch benchmarks and you can see the difference, same model on different targets, compare the hardware hardware-dependent metrics like latency, memory, CPU, power consumption. So it depends on what the platform makes available. So yeah, these are the experimental results so far. So for benchmarking of pre-trained models, so with random generating the data. So for the moment, we have this, we can report these hardware-specific benchmarking metrics for layer latency, memory, CPU, and power consumption. Not for all platforms, but for them they make it available. We have different type of devices available: Raspberry Pi 4B5, NVIDIA Orin, NXP microcontroller, STM, STM32MP2 with the neural processing unit, Intermediate X, and Qualcomm RB3. 6 different runtimes, depending on the platform, different runtimes are available. And we are now going on different integration for other platforms. Other platforms can be also simulators, can be also FPGA-based accelerators that NDT is developing, and we like to make it available for users to make launch experiments of it. So we have all these ongoing within the project first, and then we will make it available also for external community. So since this is a live platform, so we have a weekly continuous testing and on-demand testing, so that runs in the background, so that we can make sure that it is alive and everything is working right. And we also validate the results so far for some of the platforms with the online services which are available. So for example, STM32 AI Developer Cloud and the Qualcomm AI Hub, they are online services available, and we double check the results because they are the same as provided by the proprietary solution. So conclusions. We have a first proof of concept. The beta version has been released mid-January 25, it's quite recent. So it allows the benchmarking of AI models for non-embedded programmers. So we don't need to have experience on embedded programming to launch the experiments. You can easily conduct these experiments remotely and on a wide range of AI-powered edge devices and machine learning runtimes. Coming soon, so project is still 18 months, 19 months before the end. So we plan to integrate other functionalities like remote benchmarking of AI apps, meaning with pre-processing data, you will be able to bring your own data pre-processed to launch the benchmarking on these devices. We plan also to integrate remote on-device training experiments and federated learning experiments. And we plan also to adopt the dAIedge middleware that has been developed within the project that relies on blockchain technology, and also the integration of other AI-powered devices based on RISC-V, spiking neural networks, FPA, NPUs, and other AI chips emulators. So this is the roadmap. We will read it. And with that, I finish my presentation. If you have any question, I will take it.
Yeah, a question about can the models deployed in different devices communicate with each other?
So for the moment, you launch experiment on a specific device. So you have your pre-trained model and you launch the experiment, you get your benchmarking metrics. In the future, so we plan to integrate on-device training, and the on-device training will be able to run on multiple devices. So there will be a communication between the devices. So that is planned for the close future.
Not just in the training, also in the inference.
But in the inference, you mean so you just cut your model in different parts, and then you launch the inference in different or in a batch.
I'm thinking more when problems have to be solved collaboratively with different agents. For example, a group of satellites that have to do a list of tasks. So which model will decide what task to do, will communicate to other model, I have already done it, so don't do it, try something else, or give me some information of this status once you have it.
So this use case has not been planned, but really happy maybe to discuss with you. So in general, everything will be possible. So you will be able to have different tasks which are deployed on different devices, which they communicate with each other. They have a scheduling mechanism so that you can just trigger each part at each time. So this, in principle, should be feasible because we will be doing it for the training part, distributed training. but we have not planned as it is right now. The idea here is to support non-embedded programmers to easily get results that allow them to take decisions. So if it's required, so for, I mean, you already know which device you will be deploying it on it, I think you will have better solution is to deploy it at your facility. You know, you can launch each task in the available resources, take the time, and at the end, once you want to build your complete app, you do it locally at your facilities. The idea is to have a tool that allows you to take decisions easily before buying and setting up the complete environment. But yeah, principle would be possible. Yes,
yeah. So for the VLab, how you already launched it, right?
Yes.
In mid-January. And how many users that you already have it? And at one time, how many testings that you were able to host?
So the tests, they are done online. So it maybe depends where you want to launch your test or your benchmarking test. And depending on the size of the model, it will last longer or shorter. So that's and if there is one platform which is busy, so the other request will be kept in the queue and then it will be served when it is available. So that is for the scheduling of the requests. Now on the user side, we have 20 users right now that requested access to our virtual lab. So mostly we open it for project partners are beneficiaries of open calls, so that they will be using it within the frame of the project. But I mean, once if it's successful, so we will open it for other users. Don't hesitate, you can ask the request and access, and we will just evaluate, provide a good person, and then we will grant you access.
Thank you.
You're welcome. Yes.
So at the moment, I assume that you have purchased all these components and you are the owners of the hardware, but that could be also a great marketing tool for the future. So maybe you could have some companies who want to be visible on this platform to showcase their performance.
Yeah, exactly. Yeah, I mean, right now it's not only at our facilities, but also some project partners' facilities. They own different nodes. It will be open to other project partners which are developing, for example, accelerators. But for sure, other companies that like to open the possibility to the clients to launch experiments on the platforms, they can actually, I contact in HiPeak in Barcelona, a company startup in Barcelona. They are doing their own hardware. They have now an emulator, this PA, and they would like to make it available for the clients to launch experiments on it. And that could be a very good channel for doing that. Exactly, yeah. I think it's something that makes life easier because not the data scientists are embedded programmers, and yeah, sometimes it's quite cumbersome to do.
Is it always the same platform which is the best, or do you see some differences? Sometimes one platform works
yeah, exactly. I mean, in Edge AI, we realized that you cannot anticipate which platform maybe will be the best for a specific model and which runtime, for example. So you have to make the experiment, and then you will then compare the results, latency, and then you will see, okay, this runs is faster in this platform than other. So it depends maybe on the architecture of the model, the operators you see, it's very, I mean, you cannot anticipate, you cannot estimate which will be the latency. So this is a way of making these experiments much faster. There was another question over there.
Not really. I'm actually from the AI on-demand platform, and what you presented here is exactly that the architecture would be very much aligned with the AIoT that we are going to present tomorrow.
Yes.
So like any project, it comes to an end, right? So then all of these will be continuously to be whatever will be the sustainability through the AIoT, with also whatever the deployed AI is in developing. So the gentleman's point is that companies will be also beneficial to use your experiment here. And then if it is somewhere on that AIoT, then it will be a long-term things. And then so what we have discussed, I used to be from IBM before, and then when we was discussing about the dAIedge, and I do agree with the chair of this, is actually that it is one of the key aspects that we are focusing on, but also we need more investment on. And it's a bit kind of pity that we see here not too many of the partners that will be here and trying to focus, because that is, so in whatever that the US has been very strong in, and also with whatever China is doing, we are in kind of like a spot that we need to find our niche, to really focusing on that. And with these kind of capabilities that we have here, and also with the knowledge gap and also skill gaps that you already pointed out, we also need to focus on where we could be actually making the difference, and then hold up to whatever that we have been pushing forward. So I think this one would be, so tomorrow when we talking about that, and we would be very much welcome this will be integrated with our platform, with our tech team as well, because we wanted to have it before. Yes,
we're very happy to integrate it. It's our mission also to integrate with the on-demand. But okay, let's discuss also later on how to maintain it, how to enlarge it, and that's something that has to leave, and it will be a pity that it disappears. So so happy to discuss.
Thank you. Very good.
Yeah, this is exactly what I was going to actually I thought we wanted to conclude on how to spread our wings, right? And to plug into useful or result into a useful platform that it can survive and grow. So we try to start promoting the concept of dAIedge cluster. It's a bit early for us. We were not able to kind of have this presentation with the presentation we have. However, a welcome guest in the form of a coordinator from Prevail who's going to say a few words. But so we went into this process, going to be accelerating the back end of the project now, to reach out to relevant projects and relevant platforms. So obviously, AIoT is one. Deploy AI, I think it's a bit early to understand exactly what the engagement model is, but if they go through the AIoT platform as we know it, it's going to be relatively trivial because we have some experience how to integrate with AIoT, having done it for earlier projects. But that we identify a number, and it's still early days, we identify a number of Edge AI projects. Edge AI, which is a sister project that we have quite a few links with. Edge AI Trust. I was in London. I attended the launch event of the UK Edge AI Hub, which is a good way to rekindle our links with the UK. And yeah, the idea is going to want to do something useful that contributes into sustainability of this. So on those words, I wanted to see if our guest here, Sergio from Nicoletti from Prevail, can say a few words on your particular project, which is a sister brother project.
Yeah, in principle, there was a misunderstanding, and I was not able to send a few slides for the pitch. We can have access to the website of the project, actually, so you are welcome to visit it. Few words about the consortium. We are IMEC, Fraunhofer, VTT, and CLET all together in this project, and the idea behind the project that has been funded by the European Commission and by the member state is to provide the possibility to a standard user to come to see us and develop their own chips on the design that the user has developed by themselves. We were talking about the opportunity of having a better match between the hardware and the software. This initiative goes directly in this direction, and we believe that this is a good way to promote it. By the way, let me mention the fact that the European Commission now is launching a call for projects, for proposals dedicated to the use of the pilot lines We are one of them, even if we are technically a TEF, text and experimentation facility, and they will be supporting with 20 millions plus 20 millions from the member states, which means and plus the equivalent amount from the, I would say, from the user themselves. So there is the possibility to have funding in order to design their own device, have it fabricated, and implement all the application on it by the project. So we are offering basically three types of technological pillars. We have the possibility to have chips fabricated on a base of on a CMOS base, integrating non-volatile memories, basically based on Oxfam, FeRAM, or MRAM cells. And obviously, the idea is that you can freely design your own chip according to the application, and using a node, which is the 22FDX, basically, for the implementation. And the idea is that using that, you can have a chip state-of-the-art in terms of the performances and integrating non-volatile memory that are not available elsewhere. The second technological pillar that we are offering is any capabilities in order to use a 3D technology for stacking different chips either together or on a single sort of 2.5D environment, having an active interposer that can link the different chips and taking the advantage of each chip separately. And the third technology that we are offering is integrated photonics on silicon. Turns out that recently we have seen some of the, implementation using photons and peaks, photonic integrated circuits, to do, for example, vectorial matrix products very fast, because of photons can travel actually much faster than electrons. Obviously, the size of the chip is bigger, but you can gain a factor of 10 or 100 with respect to the standard speeds transferring information and doing calculation with respect to the same kind of applications using electrons. So, well, I just suggest to you to go to the website. It is a private project. You can find it, or you can contact me. I will leave a few business cards over here. So if any of you is interested, go to the website. The website is constantly evolving, giving more and more information concerning the technologies. You can register yourself in order to have information, and well, and then contact me if there is any interest on your side.
Thank you, Sergio. Thank you very much. So again, we're going to try to expand the reach of our NOE kind of wrap around the edge AI matters. The primary, can I get back the yeah, thank you. So the primary focus is going to be in the shorter term is to integrate and interoperate with AIOD, which is the well-established platform of reference. So we've already done some work to identify what is the IOD API and the metadata schema, and effectively they provide a comprehensive catalog and with an interface that allows you to basically discover assets and certainly discover the metadata of the assets. It's not yet into a full in and out push and pull integration, but we plan to basically make available the relevant results of dAIedge and possibly the benchmarking tool to the Saudi using whatever connecting technology will be available. I think at the moment, I think it's a metadata catalog, which we're familiar with, so it should be relatively trivial. And I'm going to send you the regulation chart on the interoperability graphics, but we think about making also some data available, some benchmarking available again, and we have to finalize the actual workflow to define what and when we're going to make that available. But we'll have discussion with the colleagues on the technical side to find the most appropriate. I think it's still Javier. Is it Javier from Zaragoza? Yeah. Okay.
And we also have others from Spain as well. So probably we can reconnect after this and see how we push it forward.
Absolutely. Yeah. And if there's any change, we'd love to hear what the roadmap is for the integration methods. If they are to evolve, we need to know in good time also to be able to.
Tomorrow we would have some examples of that, other projects already integrated with the platform, so we can actually see from what they have done.
Okay. What's certain for us is the connectivity with Deploy AI. I think I understood from this morning talk that it could be unified approach to the AIOD being in its actual own construct. But we'll be waiting for that to stand. And also we're making a contact with Deploy AI to understand what their engagement model will be, because they're very close to enterprise. They possibly also be thinking it's quite valuable to have the benchmarking tool, which is very, very actionable for an enterprise. So so I mean, thanks again for listening. Just wanted to maybe start a bit the discussion here and start with maybe some questions from us to the audience, and then get your questions. So the first one will be what, if you want to share with us your experience with the LOEs in terms of how you connect with them, how do you see their role, what can be different as we are making recommendation ourselves to the Commission in terms of that kind of next phase of life. So we're happy to hear from you if you have any particular comments or suggestions to make. No, then we'll I guess we'll go to the next question, which is how do you collaborate today with the broader ecosystem, and what do you think would be the useful tool to be more connected with your peers and other projects and other initiatives? Yes.
So from LEITAD's side, we are already part of FSTP program, where we are trying to work for, it's called Aid for SME. And we're trying to deploy AI-based software solutions for different industries, so batteries, PV. I think it will be interesting to talk to other partnerships to see if there are any STPs which can be developed and bring those use cases here as well. That could be one approach. Then there is another part.
So you mean to amend the way FSTPs are being run today, or to change their, what do we need to be changed?
So in those FSTPs, they are still at the beginning stage. And so you can work with them to see how we can develop open calls, not to duplicate what you have been already doing, but rather create complementary issues because you're complementary, because you have experience on it. You have known what are the challenges can be done, you have faced during opening these calls and so on. So creating open dialogue between these projects. But this is with other partnerships. It's not for partnerships coming from Adra. So creating open dialogue with other partnerships. Another point will be also from the venture capital side. So we also have a department of LEITAD Ventures, which is working closely with startups and so on to try to deploy solutions. I think this is very interesting to have a network here and try to involve venture capital at the beginning to bring in early stage or even pre-stage so-called ventures and so on to access these networks, because eventually at the end of the day, you want to have a commercial output of this network, whatever has been deployed here, the edge, AI on demand, and so on. So creating sort of kind of open dialogue maybe would be also useful from the venture side.
Yeah, absolutely. And then again, we in the second part of the project, we're going to develop this concept of the virtual incubator, which should cover some of those considerations. And I would invite you to make contact again with us to see if there could be any collaboration possible there. We realize it's needed to triangulate between the results, the users, and the financiers to have this flywheel where effectively a real usage at scale comes out of those efforts. So again, barriers. I mean, we all know there are barriers. We're trying to break some of those barriers by putting online some network activities. Beyond the usual events, we're also trying to have collaboration by design, by having new networks that are like the VLab, which are actual technology network as opposed to talking shops. Yeah, I mean, yes.
I have a question about this VLab network. I understand it's decentralized, so it has the ability to gain more partners that have their own embedded devices, and they will follow some protocols that you have established to provide these devices as part of the VLab infrastructure, correct?
Yes, absolutely.
What kind of partners do you look there that will be within this network of projects or even broader?
So the first phase is open for the project partners, dAIedge project partners, and open call beneficiaries, and then open to other networks of excellence in this AI house. And then in the third phase, so it depends on the exploitation plan.
I've seen the open call, it has many different applications, very interesting. Some of them will utilize all the already VLab you have. But also perhaps some of these persons that are involved in these open calls will provide their own embedded.
Exactly. There is one, I don't know if you just to have
a
look, there is one of them which is for integrating new nodes in the virtual
okay, so it's targeted, it's clear.
I think it's got relatively has to be staged, right? Because we can't jump immediately to a commercial open VLab that anyone can log in, and we start to bootstrap it with the network, with the existing partners, then the open call participants, and then hopefully at the exploitation layer we'll be able to plug it into the AIoT to be basically the place where it's being consumed. So we don't have to do all of the duplicate the outreach effort that they're doing. And then we have at every level we need to do some consideration for IP, right? Because once you go totally in the open, suddenly the world becomes much more based on regulation and IP and contracts. So up to now, it's still research to be clear. But we like it to be make available for experimentation, and we'll make sure that we have the right IP kind of workflow behind that to make it open. So we need to be careful in the way we open it to be outside.
Okay, it's clear. Thanks.
So yes, any questions? Any thoughts on either the NOE concept or the dAIedge, the edge AI concept, or the commercialization concept? This is basically we're touching three interrelated topics here in this project. We certainly hope that you'll be a stakeholder. Could mean well, the minima. Watch us through the social networks, but also possibly. We're going to have a series of events coming up that try to do this triangulation between results or services, the AI talents, the users, and the investors. So we'll if you leave your detail, we'll invite you to those events. We have some open calls on the way. I think the deadline is early March. So time is counted, but it's still open for projects to be developing, and I think there are 10 or 12 challenges that we want to have. So some of them could be using or will enhance in the VLab. And yes, that's that we are. And we hope to push the frontier of edge AI a bit further over the next couple of months.
Thank you.
Thank you very much.
Yeah, we have 15 minutes for coffee before we come to the final session.